All right. Welcome everyone to the Elevations Geospatial Summer Series. Thank you to our platinum sponsor, Nearmap, our gold sponsors, Wolpert, the University of Wyoming Geospatial Information Science Center, Frontier Precision, and our silver sponsor for the week, Datamark. Thank you to all our presenters and instructors as well. We are using Zoom webinar where all attendees will be on mute. These sessions are being recorded. There is a Q&A option to ask questions of the presenters. There is also a chat feature which should be used for technical issues and will only be visible to presenters and the host. If the presenter opens up the session to attendee participation and you would like to speak, please raise your hand and you will be unmuted. So with that, I'd like to introduce John Joseph and Drew Fioranelli and their talk on the moral imperative of GIS for public safety. Take it away, guys.
All right. Well, my first note at the beginning of this presentation was housekeeping. So thank you for all the housekeeping items. That was great. I will throw out here for you guys that, throughout this presentation, we really want this to be as much of a dialogue and shared content sort of thing with you guys. So you have an opportunity to ask us questions throughout the presentation. So we will be stopping intermittently to go through and take those questions from you. So feel free to go ahead and submit something into the Q&A session, and either myself or Drew will try and make sure we get those questions answered as we're moving through the presentation material today. As Brian mentioned, my name is John Joseph. I've been working in the GIS industry for about 23 years. Spent about the last 10 years of my life really devoted to GIS for public safety. I am a former regional account manager for the folks at Esri. I've also been a regional account manager for Motorola. Spent my career kind of in this industry. I currently serve as a commercial advisory member for the state of Idaho Apconina chapter. And of course, I'm joined today by Drew Fioranelli.
Hey, John. Good morning, everyone. Thank you so much for having us here today. This is always so exciting for John and I. We love connecting with you guys. We love supporting these types of events and having these conversations. A little bit about me. I've got about 20 years of experience in GIS, but mostly at local government. I have built GIS shops. I have managed GIS shops. So if you have any issues related to GIS locally, call me because I've dealt with it. I promise you. So really got into the NG 911 conversation a few years ago as a county in Northern Virginia that was making the transition to NG 911, and really put a lot of strain on the GIS office to try and figure out, all right, we've been talking about this stuff for 10 years. Now you're telling us we have to do it. How do we do it? So a lot of trial and error and really figuring out how GIS fit into NG 911 and how workflows were going to change for myself and my staff. And I was able to bring that knowledge and that experience into these types of conversations where we've built these presentations to not only introduce you to NG 911, kind of start defining the role of GIS and really kind of point a spotlight at GIS and data to really highlight why it's so important to focus on the data aspect of NG 911, not just the plug and play hardware software. So this is going to be a really good conversation. I'm super happy to be here. And John, I'm happy to be here with you, man.
We don't get to do this very often.
We don't.
We don't.
Absolutely.
So today our goals for the afternoon or for this morning is to really go through and define the principles of what is a moral imperative. This seemed like a very a real reach when we started talking about what do we want to talk about, and with Rich and what do we need to cover. And we wanted to make sure that it had, number one, a great title, but something that really emphasized the importance of what it is we're doing with GIS for public safety. So we're going to describe for you kind of the underlying deficiencies of the current E911 environment, or what they might call a legacy 911 environment for public safety. We're going to examine what that impact is going to be as they move to NG 911 and these new data schemas. I know a lot of people out there have a ton of questions about, what are these NINA standards and help us understand this component of it. We're going to try and provide you some examples of best practices when it comes to data management and help you identify some potential issues you might find within your data and your workflow that exists today. And obviously at the end, we want to really summarize for you, what individually will be your role that you're going to play in helping us move this forward. So what is a moral imperative? Well, this is also known as a categorical imperative. And it's a concept that basically, said that a moral imperative is the thing that society, as a society, we recognize as our obligation to kind of uphold the principles of our actions as sort of a universal law. In other words, to take responsibility for our actions because we know it's the right thing for us to do. We do our part because we expect that others are going to do their part to help us all achieve the same goal for a universal outcome. So this means that we have to feel pretty strongly about these principles that are kind of compelling us to take action. But that's not necessarily true. I mean, we don't have to be ready to go ahead and start marching into the streets for this sort of thing. I want to kind of help you envision this in a way that might be helpful. Let's pretend that we're walking through the park. We see some really pretty flowers. Now we recognize that it's probably not the right thing to do to go through and pick a bouquet of those flowers and take them home. It's not because we don't think that those flowers will look beautiful in our home the same way they did in the park. But we recognize that if everybody was to go through and pick a bouquet of flowers, there wouldn't be any more flowers in the park anymore, right? And so we don't do it. We want to enjoy the beauty of those flowers in the place where they exist. So when we think about this concept of this moral imperative, and by definition, what it means is that, it's based in logic and reason. It's not something we do that's forced upon us, but it's a decision we make, understanding through kind of thoughtful conclusion that what are we trying to achieve? Any action to the contrary, or lack of action to the contrary, would really be destructive to the goal, whatever that goal should be. It doesn't matter whether you want to be moral or not, right? This moral law is kind of something that's binding on all of us. It's this internal compass that drives us towards our decision-making process. And so the guy that came up with this concept, his name was Immanuel Kant. And number one, this guy lived to be 79 years old back in the 1800s. So, I mean, that's an achievement all by itself. Most people didn't make it that long. He was a philosopher, and he tried to work out how society could do and be good and kind to one another. He has some really interesting views of the world, although he never traveled very far from where he was born. In fact, I believe he lived and died in the same city he was born in. Can't believe that in life we're in this constant struggle between our better selves and our passions. This is a much better picture of Immanuel Kant, I think. As we're kind of struggling through that constant battle between our duty and our pleasure and what we want to do, we have to kind of define what are the objectives we're trying to solve for ourselves, what we're trying to solve for society as a whole. So Kant wrote, he says, act so that you treat humanity, whether in your own person or in that of another, always as an end and never as a means. So what did he, or by mere means, I should say. So what is he saying when he says a mere means? To use someone as a mere means would be like using your coffee cup, right? This coffee cup has one purpose. If the coffee cup was to break, I probably wouldn't use it anymore. But, in the end, what we're really saying is something we're probably all very familiar with, right? Do unto others as we would have others do unto you, right? Kant's view on this subject was, basically to say, we are our own ends. We are rational, autonomous beings. We have the ability to set our own goals and work towards those individually. We shouldn't take others for granted. We are an end unto ourselves, right? So we recognize the humanity of others. And we place value on those people and their humanity and the goals and objectives that they have, just as we would for ourselves. So that was the concept behind this moral imperative we want to share with you. And I think as you go through the remainder of today, you're going to get a chance to really understand what we mean by the moral imperative of GIS and public safety. So let's take a closer look at defining our roles within public safety. Knowing what you know now and defining what those roles might be would be really helpful. And I've asked Drew to kind of help walk us through this.
Absolutely, John. So first, we need to really take a look at who uses GIS, because this is where we really start diving into that moral imperative aspect that we're presenting on as this topic, right? Because it seems a little far-fetched at this point to think, all right, I heard what you just said about Kant and moral imperative, but I'm not connecting the dots with GIS or what I do with GIS, right? Well, it goes back to that duty pleasure, that push and pull, because it's easy for us as GIS professionals in engineering or health and safety or emergency management, forestry, parks and rec, whatever we're doing as our job in supporting the GIS component of our role, really most of the time where we're thinking is how we're managing that data or managing that GIS to support what my role is for that industry. Right, but as we get into this really hardcore NG911 public safety conversation, it's going to force us to think beyond where we currently are. We have to think upstream and downstream from a data perspective, from a data management perspective, from data usage outside of our own. And that's where it's morally imperative to start having these conversations and to start thinking this way. Because as we see here, there's a ton of people that are using GIS, both locally, regionally, at a state level, and nationally. Heck, let's even go international. And that continues to grow as the technology continues to advance, right? We can identify that GIS is evolving at such a rapid rate right now. It's tough to stay on board with it, right? But we also know that we don't have to worry about all the stuff that's in here in this cloud. We're going to identify what we need to execute our jobs at the highest level possible, while also thinking about what's coming so that we can start figuring out how to implement new technology, new process, new purpose to support our current business practice and what else may be impacted by the data that we're managing. Right, and I'll tell you, this list continues to grow, adding people like finance, really diving deeper into health and wellness and public safety. So it's a great time to be in GIS right now, and it's a really great time to be having this NG911 conversation. But let's really look at the GIS professional themselves, because that's who we are. So as someone who has been in GIS for such a long time and primarily support city and county government, I never really envisioned myself as, important or really a factor with public safety. Sure, I manage my data. I send it to the folks at the police department. I send it to CAD. They updated their CAD maps, but that's all it was, because I really wasn't a player in that space outside of providing GIS data. Right? But GIS as a function, we know supports other entities, not just IT, not just planning, not just permitting, not just transportation. Those we get because we've done that for so long. We've been in that space for decades. The new player to this space is public safety. And that's where this conversation is really going to dive deep into, right? But it extends beyond just the points, lines, and polygons that we're using to build maps and to tell stories. We have to think about data attribution, or how it can be limited to systems we're currently supported or needing to expand to support soon systems like public safety and CAD. That's a part of the conversation that we spend a lot of time on, but we're also seeing it's hard for people to identify with data attribution and really kind of what role they play in supporting new attribution. Because most think that it's an all or none aspect, and it's not. And we're going to get into that later and show you. But then we identify that there are other individual stakeholders that may serve as liaisons to GIS for public safety, where I may be the GIS professional in my locality, but the county next to me may not have a GIS person on staff. So who's the individual stakeholder that's responsible for managing that GIS data, or making sure that there's GIS data to provide to public safety, to the tax assessor's office, or to planning? I need to start identifying who those players are as well, because they're going to be important to my team as I start building this out. And that's really where we start understanding and really focusing on GIS staffing patterns, because they're different for every locality. For the large majority of my career, I was the only GIS person in my county or in my city. Was the only one. So you can imagine how many hats I wore. I know there's a lot of you on this call right now that may be the only GIS person in your locality. You may also operate GIS as a secondary role. A lot of folks in planning, a lot of folks in the tax assessor's office are identified as planners or tax assessors, not GIS professionals, but they have a GIS component to the function of their duty and their role, right? So how does that impact data management to support existing systems, and how will it affect managing data for next generation 911? That we have to start getting into and start having these conversations to really understand role. Now, where it gets really interesting is if you have no GIS, or if you're outsourcing GIS, meaning you are managing and maintaining spreadsheets locally to add new address points, add new roads, and you're supplying that to a third-party vendor who is making those updates for you and then providing data back to the government as a whole, your city or your county. What role do they really play outside of managing the data? Would they be considered the data owner, or just the data maintainer, but you are the data owner? Although you're not labeled as a GIS professional, you're still responsible for the accuracy of that data and responsible for the maintenance and the upkeep, even though somebody else in another building or another city or another office is actually keying the buttons in. So those folks have to be part of these conversations early as well. Now, when you're in an enterprise department, it can get a little more isolating and siloed, because you have individual components that are showing responsibility for different aspects of government. Whether they're supporting a specific department or they're managing a specific database, you can distribute and allocate resources better, but that doesn't necessarily mean that you're always connected and communicating on the same level, right? So my responsibility was to support the planning department, but I rarely had conversations with my staff who was supporting Parks and Rec, or supporting the assessor's office, or even supporting public safety. I need to know what they're doing, what changes they're making, what updates they're making, and not just rely on getting a new copy of a data set or a geodatabase once a month, twice a year, once a year, whatever. I need to start connecting to those workflows, because that's going to impact how that's going to impact my workflow moving forward, and really making sure that we're communicating together, right? So there's a real need here to focus on GIS for public safety, because we can identify there's so many different players, or if there's only one player, how many roles that one player has, and how they're going to identify and set aside resource time to make sure this stuff gets done. And it's a hard conversation to have, and sometimes it's even harder to identify, but it's not impossible. And that's where I love this slide, John, because there's no truer statement than, so this is actually something I made up. If somebody can quote this from somewhere else, please correct me. But really, heavy is the head that is responsible for all things mapping. And it's it's not that we're just piling data on our shoulders. We continue to pile hat after hat after hat after hat, responsibility on top, because you're the guy, you're the girl, you're the person, you're the one who people come to when they want a map. Well, you're also the one that recognizes there's so much more to GIS than just a map, right? You can't build a map without data.
Drew, I think I just saw a visual nod from everybody that's attending the session. You know,
oh, it's tough. I know. And we recognize this because we've been in this situation, right? We've also been in the situation where we have a stack of a to-do list on our desk that really kind of gets pushed aside when the county administrator or the city director or the fire chief or the sheriff walk into the office and they want something. So how disruptive is that to your day? Because that's someone pulling another hat asking for something while you're trying to figure out or make progress or move forward with something like NG911, like improving your data, taking time to review new edits to your data to make sure they fit existing schema or soon schema. And we had a question earlier that I do want to address, but it will be later when we talk more about GIS related to coordinate systems. That's a big one, especially when now, in this next gen environment, we're pulling data theoretically from different sources, or maybe realistically from different sources to support our transition to or our preparedness to go to NG911. Right. So again, heavy is the head that is responsible for all things mapping. What's going to impact us and benefit us moving forward with that statement is the ability to plan methodically and strategically moving forward so that we incorporate our existing practices into where we methodically can make small changes and adjustments in preparing for the next thing. And right now, the conversation is really heavy on the next thing being NG911. So you can't forget about all this stuff and focus on next gen because you're going to screw some of this up. So how do we take all of this that's already on our plate and start adding small bites to it that allow us to move forward without feeling any more overwhelmed than we can on any given day based on what's on the based on what's in our calendar. And it's hard and it does feel overwhelming. I have been there. I have beat my head against the wall trying to figure this out. And this presentation exists so you don't have to beat your head against the wall.
Thanks, Drew. I think one of the things that we wanted to also kind of give you a perspective on, and we knew that most of the people that are probably going to be on today's call were really coming from a GIS background and may not necessarily really understand 911, PSAPs, what these 911 professionals do and how that's structured. So we wanted to kind of give you a little bit of an overview of that as well. So that way it kind of could maybe help put a little bit of this into perspective for you around 911 as a whole, and what's the difference between what we're doing today and what we're trying to do in the future. So when we think about, public safety answering points, a PSAP, right? There are two different types of PSAPs out there. There's what we call a primary PSAP, and there's also what we call a secondary PSAP. Generally speaking, you're going to have secondary PSAPs in larger metropolitan regions, something that where you're going to have multi-jurisdictional type scenarios. You might have a county supporting the city, and the city has a PSAP, but they are considered a secondary PSAP to the county, things along those lines. Another thing that's been popping up here more recently, a lot of people don't really understand, is this concept of what we call an ECC, right? So an emergency communications center. Those are oftentimes much larger PSAPs. I would define an ECC as being almost like a newer nomenclature for the PSAP messaging, because they're really trying to kind of move away from being perceived as just the equivalent of like a taxi dispatch service, right? We're dealing with life and death, and yet they definitely want to be recognized for the role they play in emergency response. So ECs, emergency communication centers, and PSAPs are almost interchangeable in a lot of ways. So definitely kind of have that in perspective when we talk through this concept of a primary PSAP and secondary PSAP. We want to make sure that was clear. The thing about 911 centers is that they have many, many different roles. There is the call taker. This is the 911 person that is answering that call. They are dealing with not only 911 calls, but non-emergency calls. It's been my experience, and especially in smaller, more rural places, a call taker could be anything from the administrative assistant for the sheriff's office that happens to sit at the front desk, and so she's kind of multitasking between people that are walking in to get driver's licenses at the same time that she's trying to go through and be a call taker and taking in 911 calls. And that's not a problem if you're only getting 300 calls a year, right? But it definitely changes when we move into these larger deployments. And depending on the size of that organization, this person could fall into all these different types of categories. They are really the first point of contact in an emergency. They provide direct information to the callers to give them instructions about pre-arrival information and preparation for law enforcement, fire, EMS arriving. They're operating the CAD system, putting in all the notes. That information can then be shared downstream to the other folks, either the first responders that are going on scene or dispatch supervisors, others can actually monitor what they're doing as they're putting in this information. And they really are the core of kind of adding all that information that's coming directly in from the 911 caller. Now, dispatcher, is really in a different role. Now, like we said, this could be the same person wearing multiple hats, where they're not only are they taking in that 911 call, dealing with the panicked mother with the child that's fallen in the swimming pool or something like that, but they're also trying to communicate via radio communication to fire, police, EMS at the same time. They are providing pre-arrival instructions to the police and fire as well to go ahead and manage. So they're really multitasking throughout this entire process. They also are going to be integrated with the CAD environment. They're going to be monitoring those field units, but it's all within this kind of structure of trying to kind of coordinate the response that's going in. Now, the dispatch supervisor is another role. The dispatch supervisor is really the first line of support for the 911 call taker and dispatcher. When things go wrong, this is the person that you turn to for answers. They are not only responsible for kind of managing personnel, but they're also responsible for coordinating efforts. If you have to go through and reach out to a neighboring jurisdiction, you have to go ahead and have multiple units responding. They really facilitate making these things happen. If you have a rollover accident on the I-5 freeway and you're getting in 75 phone calls simultaneously, they're the ones that are kind of divvying up and saying, okay, you 3 people deal with this accident. Anything that's coming in from that area, that's all going to you guys. Anything else, everybody else is supposed to handle, because we don't want to lose a person to a heart attack because their calls weren't getting filtered into the system quickly enough, right? So we're trying to go through and kind of multitask. So dispatch supervisor plays a huge role in that. They manage those internal workflows, they handle complaints, and in some cases they may even be an MSAG coordinator. We're going to talk a little bit more about MSAGs later, but they could fill a lot of hats, very similar to our GIS folks, right? Now, the PSAT manager or dispatch manager, right, is really the executive leadership of the PSAP. They are responsible for coordinating all of the needs for 911. These folks in smaller jurisdictions, this could end up being the sheriff himself is defined as being the PSAP manager. A lot of times I know I've seen it in small jurisdictions where it's the undersheriff or a lieutenant. The communications that's basically responsible for kind of managing the PSAP. They don't often have their own dedicated PSAP managers in small jurisdictions compared to other places you may have those sworn officers. They kind of serve as like a liaison between the MSAG coordinator, the 911 systems administrator, the CAD manager. They are really the ones kind of behind the scenes. And additionally, they also manage the financial aspects of the PSAP because they have to monitor every dollar that gets spent for the PSAP and where those dollars are going to. We can't take in 911 surcharge revenue and spend it on new vehicles or guns and light bars, right? We have to spend it on the things that are important to 911, staffing issues, and so forth. And generally speaking, these folks really don't have enough money to pay for their own staff from those dollars. They're actually having to ask for more money from the cities and counties that they serve. So they have a lot of responsibility in what they do from a financial standpoint, as well as the management of the PSAP itself. So let's talk a little bit about an MSAG coordinator. So what is an MSAG? Well, an MSAG is a master street address guide. Now, a master street address guide is something we'll be covering a little bit more detail, but you have to understand this is a database that runs from within the legacy network. It's what defines where a 911 call is routed. How does a 911 call get into the system, and where does it go? And it has a purpose behind it, of course, because it's basically taking in the street center line and the range values that are associated with that street center line. A lot of the people that are working in the role of an MSAG manager today are not GIS people. They don't really understand GIS. They're really maintaining this as an Excel spreadsheet, right? So they maintain this list of street center lines and values independent of the GIS work you're doing today. And we're going to jump into a little bit more of this later to help explain that. And of course, let's talk about a 911 authority. Now, a 911 authority, is really by definition either a state, county, or regional government entity that serves as the coordinated 911 service operations leadership. You may have many secondary PSAPs within a jurisdiction. They all kind of link back up to a 911 authority. There's usually a 911 board that's associated with that. The hierarchy of kind of not only managing jurisdictional responsibilities between these multiple jurisdictions within an area, but at the same time, a 911 authority, especially in a more rural area, could be just the county administrator. The 911 authorities scales, right, based on population. So it's really important to understand that. And of course, I think in places like Colorado, we have things like the emergency telecommunications authorities and so forth, who I believe really do kind of play that role for us as 911 authorities for our regions throughout the state of Colorado. The role of a 911 authority changes in an NG911 environment. And that's really important to kind of understand the terminology and how some of these things are going to be modified when we talk about NG911.
So John, all that's great, but I really think we need to show an example, really kind of defining why GIS for public safety is a moral imperative. Because we've talked a little bit about GIS, we've talked a little bit about the PSAP and the roles of the PSAP, but we need something to kind of connect the dots now so that it can start to make sense. What do you think?
Absolutely. I'm right there with you, and I totally agree. And I think if you guys can just bear with us for a few minutes, we have something here we'd like to share with you to kind of give you a perspective of what's kind of driving this motivation for change.
I'm in a car in a lake. Where?
Were you able to pull the address up?
I don't think it's ours. It's not on our map.
Did she say where she is?
We're trying to find you on the map, sweetie. Your cell phone's hidden, okay? Ma'am, I lost her.
Lost on the line, Gannett journalists investigated 911 across the nation and discovered dispatchers are having trouble finding victims so often, the FCC's new goal is to locate just 40% of cell phone callers 2 years from now.
I cannot get this address to come up.
And they're screaming, call 911. I'm trying to find you on our map.
You can't find the address?
No. For what address, ma'am?
Give me the address one more time. It's not working.
Trying to find where she was, no instructions were given on how to save your life because they were so focused on, well, where is she?
19 minutes ticked away while rescuers searched for the pond concealing Chanel Anderson's sunken SUV. And 29 minutes after she first called 911, firefighters pulled her out, too late to save her life.
Ma'am, man, move your L very quickly. What lane? Fairway? Off of Batesville. 30188.
She told 911 where she was exactly. And for them still not to be able to locate her is insane.
We typed Batesville at the fairway into Google Maps and it came right up without using road or street or the zip code like the victim did. But 911 doesn't use Google Maps. Instead, they use computer-aided dispatch. This is a computer grid connecting the radios and the telephones to GIS, the Geographic Information System. This is a hyper-accurate proprietary map that has every house, every firehouse, every fire hydrant in the city. But it has one fatal flaw. It stops at the city line. If you hit a cell tower outside their jurisdiction, they don't know where you are.
If the phone can find us, we should be able to find the phone.
Admiral David Simpson is chief of the FCC's Public Safety and Homeland Security Bureau.
911 was the emergency.
We took Chanel's call to Washington, where it has become a call for change. What can you promise Chanel Anderson's mom sitting here today?
She should know that her daughter is a hero in this, that her death, however tragic, has galvanized a country around this important issue.
Why is it more important for a 99-cent app to know where we are than the 911 operator who answers the call?
So this is something that's not uncommon in the Peace app, right? For those of you that work in the Peace app that are on this call, you've been in a similar situation before. I know you have. As someone who's in GIS, that type of call, that misrouting, the inability to find or locate someone on a map is something that I was never really aware of, nor really understood how it happened. And the purpose of the video is not to provide shock value, but it's really to kind of really diagnose and dig deeper into the current relationship that GIS has with the Peace app and with the CAD system. Because in my 15 years in local government, it's something I never really understood. And I'll tell you, I didn't understand it. It's going to sound really bad, guys, because I didn't have to. It wasn't part of my job description. It wasn't part of my role. All I was responsible for doing was once a month or once a quarter, providing an updated data set to 911 and updating their CAD maps. I never took time, and I'll tell you, until about 4 years ago, to actually sit at the Peace app with the call takers and really understand how the data that I was managing and supporting and providing to the Peace app was being used to support the dispatchers, to support the call takers, and to support the public when they called 911. So John, if we go through that video, can we identify what the role of public safety was during that call, or a call like that?
Yeah, I mean, from my perspective, on the public safety side of the house, they were trying to find the location of a caller that was bouncing off of a tower that was outside of their jurisdiction. So for them, they couldn't physically see the location of where she was calling from. And I think when we go through the rest of this presentation, we'll be able to give you better examples of kind of why that kind of thing can happen. And it really comes down to the sophistication of our 911 network we have today, kind of falling short of what the expectations are of the community and society as a whole.
Absolutely. And I really kind of want to take this next question. What was the role of GIS? And really kind of break down the role of GIS as it pertains to that call or that video. And John said it is outside of my jurisdiction. I don't have access to my neighbor's data. So literally someone that was calling from a neighboring jurisdiction, I couldn't see where they are because I didn't have access to the data. I couldn't see roads. I couldn't see address points. I couldn't even see parcels. And I'll tell you, that was a huge light bulb moment for me 4 years ago when I learned that for 911, number one, we just think 911 has everything, right? Because we really build our understanding of 911 from TV shows.
Yeah, I was gonna say, you watch too much TV, Drew.
I do. I watch way too much TV that involves 911, right? It doesn't work that way in reality. When 911 got to the other side of the county boundary, they may as well have fallen off a cliff or entered dark space because they couldn't see anything. Sure, you can throw imagery on there and see images, but you don't see real data. You don't see data that you can ping to see that that dot is 1213 North Main Street, or to see that that road is Main Street, or to even see a parcel number with a descriptor of how to get there. Right, mind blown. I'm like, why does this happen? Why is this not something that they have access to? What can I do to support that? And I think that's where we get to this next question is, how could NG911 have helped in that situation or a situation like it?
Yeah, and I'd actually maybe try and Drew to maybe wrap two of these together, right? The how could NG911 have helped, and how did call routing affect the outcome? In the current modern day E911 environment, it is not uncommon that we will have multiple carriers serving multiple communities, even next door to one another. Their networks are not connected, right? I know in my neck of the woods where I live at, there are actually two primary carriers up here that provide 911 services. One is through Frontier, the other one is through CenturyLink. And there is a definitive line across the state where it says, okay, everybody that's north of this line falls within this, LATA, basically, right? This exchange environment for Frontier versus the one that's, for the folks at CenturyLink. And I really learned a lot about this when I was at Motorola, because it creates delays in the transfer. If they do get a call, they have to then transfer that call. I remember there was a study that was done in California where one individual 911 transfer, they measured across thousands of calls, but they were saying that it could take anywhere from 20 to 40 seconds for them to transfer a call from one location to another. And in an NG911 environment, how this helps is that we're going to all be underneath one cohesive network, right? In fact, it's truly a network of networks. Frontier can have its own next generation core services deliverable that they're going to provide to all their customers in Northern Idaho, and CenturyLink could have a completely different one, but they're going to all be able to utilize the same kind of core services infrastructure because of these NENA standards that have been developed to make it easier and better to go ahead and identify quickly, not only where did that 911 call come from, but where should it be routed to? Does it need to get sent to a different location? It's happening in seconds, in a second, rather than taking 40 seconds going through a transfer policy, all that sort of thing. So there's a huge amount of benefit that's going to be coming out of NG911 in a scenario very much like this one.
John, that's great. And it feeds right into that next question is, how did call routing affect the outcome of this call? And granted, guys, this is a very sad and tragic call. So whether it's this type of call or any call, right? If I fell and twisted my ankle or got a mosquito bite or something, any call that doesn't route correctly, right? Let's identify how call routing is affected and what can affect call routing in these types of scenarios.
Yep.
So for the call that we experienced, the caller was outside of the PSAP's primary response area, their jurisdiction. But the call pinged off the nearest cell tower, which happened to be in the call taker's jurisdiction, right? So they couldn't see information because the call was just on the other side of the boundary. So that's an inefficiency in call routing that gets improved with NG911, leveraging accurate geospatial data and boundary data to make that decision of where to send the call based on where the caller is located, not based on the nearest cell tower or the first cell tower to pick up the call. I think I explained that correctly.
Yep. Nope.
So, I think huge improvement with migrating to NG911 to affect call routing in a very positive way, and it becomes geospatial call routing. So if you've ever heard that term, that's what it means. using GIS as a decision-making factor in that function to identify where to send a call based on a boundary that call is coming from, not just the nearest cell tower.
Sorry, I thought you were ready to move on to the next slide there. Hopefully you were.
We can, absolutely.
Okay.
Absolutely. You jumped me a little bit, but that's all right.
I apologize.
You had quick fingers and a quick trigger.
I did.
It leads greatly into this slide. So GIS and public safety is evolving at a much faster pace than most of us think, right? We identified this at the top of the call, that for, gosh, the better part of 45 years, GIS hasn't really played very much of a significant or critical role in 911. Sure, we provide points, lines, and polygons, geospatial data to update maps, but where we see this improving is with the technology and the connectivity to connect data sets from different owners together so that we don't run into issues like we just heard, where you receive a call from your neighbor's PSAP, you can see the information, you can see the caller location, and you have the ability to transfer that call if necessary, right? It's bringing this community aspect together and really eliminating these cliffs that currently exist in our data. Where you're going to see that change at different levels is how fast you're migrating towards NG911 versus your neighbors or your state. In Maryland, we've seen the state of Maryland adopt this regional aspect of transferring to NG911. So you'll have 3 or 4 counties get together, go after funding to build a regional EZNet, so they all can see each other and share data and see information about each other. But once they get outside of that region, cliff. So they're cool as long as everything's within those 4 or 5 counties. But outside of that, it's going to take a little longer because those guys are working individually or collectively as a region to build out their functionality. The flip side to that, sorry, go ahead, John.
Well, Drew, I was just going to contribute one thing here, and I think that Chanel Anderson's mom really hit the nail on the head here too. Is that part of the thing that's kind of forcing GIS and public safety to kind of evolve at a much faster pace is that the perception in community. If the pizza guy can tell me up to a minute where I'm going to be when he's going to deliver my pizza to my house, why is it that I can't get 911 to recognize where I'm at? So I would say that and the combination of 9/11 and all these other types of things, we suddenly became a society that was really driven around things like situational awareness. Our technology and connectivity has completely changed where we were 45 years ago versus where we are today. Has really kind of pushed us forward in saying, we really need to have a better infrastructure for 911 compared to what we had back then, because the technology and community and situational awareness, it's all driving us that direction for public safety.
Well, John, I think we also have to identify that reality TV is changing our perception about what's possible as well.
Yeah.
Right. We can laugh about it and we can write it off, but that's the expectation of someone that's calling 911 who just watched the show 911. Right? I've heard it before. I was just watching on TV and they found me with no information. Why can't you? Or to John's example, why is it that Papa John's and Pizza Hut can find my house, but you can't? So there's also an educational component that's been missing from 911 for quite some time, and really not only educating the public on using 911 to call when you need help, but really understanding internally within our systems of what data is being used to drive those functions. Because as we heard on the 60 Minutes report, it's not Google Maps, which my soul dies a little bit every time someone says they rely on Google Maps for accurate GIS information. It's not as accurate as it can be. Accurate data exists locally, and it exists locally for a reason. But we are also we are also used to convenience and will gear towards convenience as society. So I understand how Google Maps works, and I expect 911 to work the same way. Not always the case, for good reason. We will see that improve as we continue to migrate towards next gen 911, creating better situational awareness using accurate local data.
Ready for a slide turn?
I am. This is where we actually get to talk about kind of this transition from 911 to next gen 911. So as most in the 911 space know, the first 911 call was made in 1968 in Haleyville, Alabama. And as cool as that sounds, when you actually dig into it, it was really one guy calling another guy in another building. They actually could have been in the same building, just different offices. I don't remember. But that technology was very cool for that time. However, that technology has been fairly unchanged for 50 years. The current 911 system we're using was built on copper lines to support landlines. How many people still have a landline? I don't. And as such, the databases that were used for location identification were built not to support a spatial component. It just had to make a one-to-one match. We'll dig into that in a second. We've seen improvements over the years as mobile devices became more and more prevalent, starting with pagers and then moving up to the flip phone Motorola's that would last forever, and now into really pocket computers that have the ability to make calls and transfer data. So you saw things go from basic 911, which is, landlines and copper lines, to E911 that started to see improvements on location awareness and providing location information all the way through wireless phase 0, 1, and 2, where you continue to see improvement through each phase on decreasing that ring of uncertainty around where you think a call is based on location information that could pass through those copper lines from your wireless provider and be accepted at the PSAP by your call handling equipment. But still, even at wireless phase 2, we're at a somewhere between 50 and 100 meter possibility. We're still not able to accurately pinpoint the location of a wireless caller that could be on a trail or in the woods or even in a park or a golf course. We can get close, but 100 meters square is about a New York City block. In the woods, that's tough. In downtown New York City with multi-level buildings, that's tough.
Yeah. And I would say, Drew, that there are some new technologies and kind of over-the-top solutions, but there's a disadvantage, I think, in some ways when we start talking about all these over-the-top solutions to try and solve this problem, because we're not fixing the core of the issue, which is the improvement of 911 nationally, right? So we could solve this problem in an NG911 environment without an over-the-top solution, but it's the ability for the carriers and the states and the regions to be able to go through and adopt these technologies and start moving down these paths and be able to build that support for them. So I totally hear you. You're spot on.
Absolutely. And what's important to really identify before we get into acronyms, NG911 has been a topic of conversation for 10 or 15 years. It's been around about as long as I've been in GIS. And I want to say, John, 10 years ago, it was 70 to 80% of 911 calls were made from wireless devices. I about bet any amount of dollars I got on me that's increased to probably closer to 90 or 95% now, as mobile devices and the ability to use devices that operate on mobile networks or IP networks are continuing to increase. And it's only going to increase as this technology really gets redefined and improved in cars. Your car's ability to call 911 during an incident and transfer information about the car to the PSAP. That's a wireless call.
Yeah.
It-
Well, you know, I would even throw out there that this whole concept of the Internet of Things, the idea that I can buy a refrigerator that knows how to call the grocery and place an order for what I need to go ahead and fill
Right.
it. It's, you know, how far away are we from that in the 911 world, right? Again, that's
Oh, for
all
sure.
cellular technology, cellular communications. But I'll, you know, to throw out another statistic that I think is really interesting is a couple of years back, I believe it was the FCC had actually done a study to see the decrease in landline usage. So as we've seen this ramp up of wireless calls, you know, being the primary form of 911 calls being placed, we've also seen this dramatic decrease in the number of landline phones. And so depending on where you live around the country, you know, there's becoming a predominant sort of, you know, structure to things where it's saying we don't need to have wireless, or we don't need to have a wireline phone in our house if we have three wireless phones. Let's get rid of that wireline phone. Well, that's the basis of this system. It was built in 1968. Was everybody had a landline phone. That's not the case anymore, and it's becoming more and more prevalent that a landline phone does not exist in the home, strictly wireless.
Absolutely. And we'll only continue to see that number grow as we continue to expand broadband into rural communities.
Absolutely.
Right? Absolutely. Which is going to impact your phone's ability to, your watch's ability to call 911, notifying them that you have fallen.
Mm-hmm.
Right? That's not even a call that you trigger. That's triggered by a sensor that is attached to your person. Crazy. I'll tell you, 911 in 10 years is going to be crazy. It's going to be ridiculous. It's going to be really cool, though.
Okay, you ready for the next slide?
Yes, sir. Let's talk about some acronyms. So you've already heard John and I mention several acronyms. PSAP, we identified as the public safety answering point. You just heard me mention the EZNet. That's the emergency service IP network. That's the new network infrastructure that's being built that 911 or next generation 911 will operate on. So that's getting rid of the copper lines and building this internet really to support data transfer and location identification for 911. The next gen core services, or NGSC, we define a little further better, but that's all of the core services that are used to provide the call routing functionality for NG911 and consumes your GIS data. The emergency call routing function is a function that pre-validates. So during the time, the space between you hitting send to go to 911 and a call taker or dispatcher picking up is going to trigger the emergency call routing function, identifying if a route can be identified for the call, so where to send that call. And then the LVF, the location validation function, predetermining the location of the caller. So those happen in split seconds. They use GIS data. We'll define it further better, but those are really important pieces of core services. You have APCO, that's the Association of Public Safety Communications Officials, who are doing a ton of education and providing a ton of support for NG911 and education. The MSAG and ALI, the Master Street Address Guide and the Automatic Location Information, those are both two documents or databases that are leveraged really hardcore in current state 911 to provide location identification information. For GIS nerds like me, the MSAG is essentially an attribute table for my roads, and my ALI, or my automatic location information, is a address point database that shows me where everyone has a landline is. So it connects my landline to an address point, and my MSAG identifies road segments and road ranges, right? It'll make more sense here in a second, just hang on. The list, or the location information server, John, you're gonna have to help me with that one. I struggle with it. I just don't talk about it enough.
You know, actually, we're going to cover this a little bit later, but, you know, the idea behind a location information server is it is truly a replacement for what we define as kind of our ALI. It's a pre-call, you know, database that the carriers use to go through and validate new lines of service for customers. And so the location information server is basically that. It's basically a confirmation engine that allows the carrier to go through and check against your GIS data to say that this is a valid or invalid address for new lines of service.
Absolutely. Thank you so much for providing that. And then our SI, or our spatial interface, is a part of the core services environment. That is what you are going to shove your GIS data into to support this new environment. We diagram it out later for you. NEMA is the National Emergency Number Association, or the standardizing body for 911 and NG 911. So they are the ones that are defining the rules, the regulations, the requirements, and the standards that you will be required to follow as you work towards and implement NG 911. And then an ECC is an emergency communication center. We are noticing a trend across the country of folks migrating away from calling a 911 call center a PSAP and really referring to it as an ECC, because they perform way more functions than just accepting 911 calls. So I'd be really curious to learn if you guys have started making that migration away from PSAP to ECC. And John, we have a question that I think kind of fits where we're going in the conversation. So I want to address it now if we can.
Sure.
So we were asked if we would address the FCC enforceable settlements with AT&T, T-Mobile on June the 3rd, so just a few days ago, to require cell providers to include Z-axis values on calls and how GIS will work with that new dimension. Are you familiar with? I'm not familiar with that. It's something that I've heard just rumblings about for the past couple of years. I missed that the FCC actually is going to enforce that.
You know, I'll give you a great example on it, and of course this comes from California, and you know, they have a ton of very large high-rise buildings. You know, you can imagine you get a 911 call that provides you with the location of a physical address, you know, for an office building. But that office building could be 36 stories tall. And so what they were, you know, you may find that physical address, but then you don't know what floor of the building that person might be in, where the stairwell is, because maybe they're between floors and all that sort of thing. So the FCC is trying to, you know, drive the providers to start, you know, giving that Z access, that location accuracy. But as I understand it, the location accuracy that's tied to that is within basically, I want to say it's within about 2 floors or 3 floors of a building, because it's like 50 feet, I think, of Z access. So, you know, it is going to be a new dimension of this that's going to provide us with a little bit additional information regarding how that information is going to be provided to the dispatch centers. But you know, there are providers out there today that have gone through and been working on this Z access issue as part of an over-the-top solution for quite some time, and I know that part of that has come also from the phone and the device itself, because our phones have the ability to go through and provide us with elevation, as well as the carrier being able to kind of triangulate where that call is coming from. So it'll be interesting to see how they're going to plan to approach this. Is it a matter of them providing the part of that PITA flow information that comes along with the call to include the Z access information? You know, I'd have to go through and wait and see kind of where this is going to be and how involved it's going to be with regards to the Z access moving forward. But you know, ideally, it's all about being able to try and find people in you know, tall buildings, large complexes, that sort of thing.
Absolutely. I actually have a copy of it. Dave sent it to me. Thank you for that, Dave. So here's the reality. Z is going to become more and more important as we move forward, not only for NG 911. I think we can all kind of see that writing on the wall, because we've talked about the value of Z for a decade. NG 911, I think, is going to be the catalyst that really puts a lot of focus and emphasis on being able to correctly identify Z value as well as XY, not only for improving location identification, improving situational awareness, but also as we start integrating this IoT environment, these systems of systems, connecting systems together with sensors, the ability to understand the Z value of a sensor and how it relates in that connected environment is going to create that broader picture that we're going to need to support that movement. So IoT, the Internet of Things, machine learning, artificial intelligence, all that's going to require accurate Z as well as XY. So I can imagine in the next, gosh, probably by the end of the year and well into next year, you'll see more focus turn to Z, because with NG911, we're improving XY for home addresses. Well, the next one to improve will be Z. I know that there are some vendors in the market and some CAD vendors that are already starting to put some focus and highlight on Z. It'll be interesting to see how we integrate that accuracy requirement at a local level and kind of what that's going to require, because it's not easy to do. It'll be interesting. Great question though. Thank you for sending that document, John. I'll send it to you at the end of this so that we can start reviewing it and figure out, you know, what role GIS is really going to play and really how that's going to affect you guys at a local level, because that's who will be responsible for collecting that information, either through funding or if you have local you know, it's the difference between mapping grade and survey grade. Is that possible? Great question. Thank you for pointing me to that.
So let's walk through what an E911 call delivery looks like today, basically a legacy 911 network. So, you know, how an E911 call is delivered is that, you know, you have your phone, it's a landline phone, 555-1234. That phone is sending the call through a switch. It identifies that this is a 911 call, so it then pushes it forward into what we call a tandem switch. Now, in order for that call to get routed to the correct 911 center, it has to compare two different components of data, right? It has to compare this MSAG, Master Street Address Guide, so it's trying to locate, you know, that the location of what PSAP it's supposed to based off of the MSAG and the emergency service zone numbers and all those other kind of things. It's also attaching it to the telephone number, so that phone number, the 555-234, well, it's associating that with, well, that number is associated with PSAP number 1, and then joining these two ESNs so that it knows, okay, well, this is going to go to this dispatch center or this dispatch area, and then it forwards that information on to the PSAP. There's a problem with the way that this system was created, in the sense that we talked about this earlier. This is all based on landline technology from way back when. So time has moved on. We've added different components, right? We've added in wireless, we've added in VoIP. You know, you could have a VoIP telephone. I remember I had one for work a while back where I had a VoIP phone that was from Minnesota that basically was sent to me. But if I was to have called 911 from that VoIP phone, you know, the first time that I got it plugged into plugged into my machine, it probably would have tried to locate me in Minnesota for trying to place that 911 call. I had to go through and basically register my VoIP before I could use it for the placement of a 911 call locally, because it still thought it was in Minnesota. Wireless calls, in order to make this whole system work, they have to create what they call a P-alley, right? Which is basically a phony alley location based off of the caller's tower location, which is how we ran into a situation like we saw with Chanel Anderson, is that the tower was basically outside of the jurisdiction that it was hitting or she was located at, which is what caused the problem, I believe. And of course, not having the data for that neighboring jurisdiction, they could not see beyond their own boundary to go ahead and get them routed to the right location. So throughout time, in order to make all these things work, like I said, whether we're talking about VoIP, whether we're talking about wireless, we've had to create this patchwork of band-aid fixes to try and resolve all these kind of potential scenarios of how a call should be or could be routed to 911. So let's talk a little bit more about the Master Street Address Guide. And I'm not going to try and beat this to death, guys. We have to recognize that an MSAG is truly the legacy 911 environment. It's how they manage that data. We make the association of a street name with a range value associated with that. It's saying that it's going to be the community that it's serving, the state that it's in. But it is still just basically kind of that glossary, if you will, of the location of street center lines, but not by location, strictly by name and value. One of the things that I've seen, in time is that I will gone through and evaluated MSAGs and alley against one another, and I don't think I've ever run across one that's had less than like a 98% level of accuracy, because they've been so current on them. But what people have had a tendency to do is they say, well, that's a fast growing area of town. They want me to go ahead and put this in at the 5,000 block of Edgar. Maybe I should extend that out a little ways so we don't have to go through and revisit this in 6 months, right? And that's a problem, because they will create the potential for addresses that will not exist or that could exist. And then hypothetically, somebody comes down the road to the local carrier and says, hey, I live at, this house, this address, 777 such and such. And next thing you know, they realize that they've created a false location of an address that can't exist within the system. And they can't find it if they were to try and go drive to that location. It doesn't exist. But there's no comparison between what's happening between the MSAG and the alley and what's going on inside the CAD system. So we've got a little bit of a disconnect in some ways when we think about how a Master Street Address Guide is managed, because it doesn't contain any spatial data. It's no longer spatially relevant. It's strictly a tabular database. The same thing can be said when we talk about the automatic location information associated with telephone numbers. The person comes into the carrier's site, says, hey, I want to go ahead and add a new telephone line, or I want to start up a new line of service. They provide them with their address. Well, I work in a lot of very rural communities, and what I've found in the past is that sometimes folks will be creating lines of service in these rural areas, and they will have, the only thing they have to really show to the carrier to say that this is a valid location of service is a bill. They have to show they received mail at this location. But the Postal Service doesn't dictate what 911 service areas are. The Postal Service actually has been delivering mail in some cases to somebody based on their first name and the city they live in, right? So they could say whatever they want. Oh, my grandmother's name was Betty Lou, so I live on Betty Lou Drive, and they'll still deliver that mail. But Betty Lou Drive doesn't exist within the MSAG, or it doesn't exist within your GIS data set. So therefore, that creates a problem. Alley data, again, is strictly based on tabular information. They run a validation check to see whether or not does Betty Lou Drive exist within that zone. And as long as it fits within an address range, even if that address range doesn't truly exist within the street network you live in, they will approve that alley location. And then you've got an address that you can't serve to. I remember I had a situation not too many years back where one of my counties here, they had a gentleman that had moved from outside of the area, but when he moved to his new house in the city, he brought the mailbox that his wife had painted for him. And it still had the old address number for the old house. They lived way out in the middle of nowhere. So here it is, he's right in the middle of the 100 block of downtown, and he's got a 5-digit address where everybody else has basically got a 3-digit address. But because he still received his mail, and once he got his new service, and these people were driving all over the world trying to go ahead and figure out where this guy was at, because how on earth could he possibly be wrong, right? So again, this is non-spatial data, and the validation process of how information gets updated is really flawed. And so we really need to kind of understand what goes into this current state of 911 if we're really not using spatial information to associate where a telephone number is or what a street range is possibly to be. So let's talk about that current state of 911 today, right? Location data is sourced from the telecommunication providers that, of course, as we said, kind of lacks sophistication. It's not complete, based on 50-year-old technology, right? It contains an address that is not synchronized to necessarily a neighboring jurisdiction, the folks that are near or around you. And of course, routing of a 911 call, really comes back to the public safety entering point and how current have they kept their non-spatial data, right? And then of course, the expectation is that there's a 98% GIS data synchronization as being deemed acceptable. But in reality, these folks are primarily using GIS to fall into these three buckets. They're looking at it from, does it work with my CAD system? Can I push it out in my call handling phone map? Does it work inside the vehicles for AVL? It's got nothing to do with the level of accuracy of how a call is routed to the proper PSAP. It's all about, just basically a display. So meeting a level back, that 98% level of synchronization isn't a requirement. It's just deemed, if we can get data, we can get data. When I first got into this industry 10 years ago, one of my number one questions I would end up asking to folks at a PSAP was, when was the last time your data was updated? And you would be surprised at the answers you'd get back, because they say, well, let's see, we installed our CAD system about 3 years ago, so I think that's the last time we had an update to our map, right? That's all changing. That's all changing. So Drew, I know you want to talk about this and kind of share your thoughts about why NG911 is important and kind of how this all folds together.
Absolutely. Well, it's all about creating efficiencies as well as providing more information to the dispatcher and call taker so that they can make better informed decisions. Right. It's also allowing me as a caller to provide more information to 911 to help provide a more accurate picture of situational awareness by allowing me to text 911, which I know a lot of people can already do. But think about how valuable it could be to video and show the 911 call taker or the dispatcher actually what's going on scene, providing a better idea of who to dispatch. Do I need a Jaws of Life? Do I need an ambulance? Do I need a fireman or law enforcement, or all three? And how many of them do I need? It allows me to maybe interact with social media and use social media to make a call or provide more situational awareness, improve auto crash notification systems on our cars or in watches and phones. Not necessarily crashes, but how can we use devices that are on us to protect us or to call someone when something happens, like when we fall. My grandmother fell about 4 weeks ago in her nursing home, and that fall triggered an automatic response from a device that she was wearing. It wasn't an iPhone or an iWatch or anything like that, but it's devices that they have to wear by living in the facility. So if they fall, it triggers someone to come and help. That's really cool technology. Let's explode that at a national level. Or provide medical information to the dispatchers and call takers. If I have an allergic reaction, but I can't speak and I still need help, the ability to text and transmit medical information to that call taker could save my life. So that's why NG911 is important, but it starts with rebuilding that infrastructure. We don't have an infrastructure for 911 right now that can support this functionality. As we progress to NG911, you guys are seeing that it extends beyond just GIS. It also involves that network and that infrastructure significantly to support these data transfers. So that's why NG911 is important, because it's going to help us. It's going to help us make sure that our communities are safer, as well as providing a safer avenue for me to contact help if I need it, depending on the situation that I'm in. I may not be able to call, but I may be able to text. Or I may not be able to call or text, but can turn on a live stream so that you can see what's going on at 911 so that you can come and protect me or send someone to help me.
Yep. So let's talk a little bit about, the next component of this, right? So let's talk about kind of that future state. And what I want to kind of highlight here is, the information we've been talking about, these, the address points, the street center lines, the boundaries, all this information, this becomes part of a new bucket, basically, that didn't exist before. And it truly is geospatial call routing, right? So in addition to still supporting, we're not getting rid of any of the existing level of support we have to provide for AVL, for CAD, for 911. But in addition to that, we're going to be going through and trying to meet the expectations for geospatial call routing. So this presents a complete overhaul of that legacy 911 system. It shifts the stakeholder responsibility away from the telecommunications companies and places the 911 addressing GIS authorities kind of in charge of providing solid geospatial content for them to go ahead and route 911 calls with. It's based on kind of this standardized approach for this technology we call the I3 standard. And the goal is that we're going to try and aggregate and reconcile GIS data across 20,000 municipalities. This includes counties, cities, states. Everybody's going to have this kind of universal platform. Now, that universal platform at that highest level is what they call the forest guide, and we can talk about that later if you guys have questions. But ideally, what we're really trying to build out is this one universal map that says this is the coverage area, the response area for all these different entities. And of course, we want to be able to geospatially route calls to nearly 5,000 PSAPs around the United States. Now, this, of course, is we're going to require that the GIS data needs to be synchronized beyond an acceptable 98%. Our goal is to reach 100%. Now, of course, that's it can't always be 100%, right? There's always going to be areas where we're going to have a small fraction. But, we're talking about a very small fraction of missing addresses or bad street names and things like that. And the expectation, by the way, for those to be resolved when they do get identified is 3 days, not 3 months, not 3 weeks, but 3 days. And so the responsibility is going to be much, much heavier on the GIS community to start preparing this data and rolling it out in a more readily available system. Now, I don't want to freak you out because I know this is what a lot of people get worried about, is they go, well, I can't fix all that in 3 days. Well, you're not going to have to. We have to think of it kind of like the long tail. Initially, there's going to be a really high level of effort to go through and make sure that all my data is current and accurate. But over time, it's actually going to go through and kind of spin out to where you may only be having to make 1 or 2 changes a day or a week to be able to maintain that high level of accuracy. Initially, there's going to be a strong level of effort, but slowly over time, that's going to go through and decrease because you're not going to have to be making so many changes because your data is already going to be so good. So when we think about this I3 environment, I wanted to show you what this looks like in comparison to the kind of patchwork we saw earlier in the old E911 environment where we're transferring the TAM switches and we've got all these other things that are going on. In an NG911 environment, the core services, whether your originating service provider is coming from a VoIP, wireless, or landline, is going to be transferred into this secure EZNet environment. We'll talk a little bit more about an EZNet here in just a second, but that is an emergency services IP network. And I know in the state of Colorado, you guys are already implementing an EZNet right now. The next step in this process is to go through and kind of improve your GIS data quality and eventually be able to deploy that information into your next generation core services. So this is timely that we're having this conversation. I think that one of the things I really want to hit home on in this particular slide is that the GIS data that you are building today and what you're building for next generation 911 is being used not only for during a call for service, but also prior to the call for service in that pre-call environment. We talked a little bit about the idea of an LIS or location information server or LDB, but that data is what's being used to go ahead and validate that information. So as we kind of jump into this more, we're going to talk through some more of these independent different focus areas. But I definitely want to kind of share this with you to kind of show you how different this network looks in this environment versus what we've seen in legacy E911. So we start dissecting these parts and pieces of next generation 911. we need to recognize that the EZNet itself is a network, and ideally an EZNet in different states are being deployed in different ways. I know, for instance, in the state of Washington, they have one statewide EZNet for everybody. And then even within that network, they're looking at potentially creating a ring within a ring, basically, if you will. So a network within networks, so that they can support certain areas that may be more susceptible to things like cyber attacks and things along those lines. So we constantly have this redundancy amongst the IP network. The networks are really multi-purpose, right? Not only are they secure, they support extended communications for public safety, in addition to 911. Of course, that NG911, assumes that the EZNet is going to kind of be a shared resource that everybody is using. So everybody's going to be connected to the same system. Therefore, that connection, that ability to transfer calls is going to be much faster. I would also throw out that one of the things that's really important to understand about how that EZNet works is that in addition to just receiving the voice and a telephone number like we did in the NE911 system, inside of the EZNet, inside of this next generation 911 environment, we're not only receiving voice and the number, but we're being provided location information along with that. It's all being transferred as part of what comes in the network. So that's really important. Like I said, we kind of talked about this earlier. Location information server is really a subscriber database. It replaces the role of what the alley has been in the past and starts to provide that function to go through and provide location information for new lines of service for the carrier. And then we're going to jump into some of these components what we call functional elements. And functional elements are really about things that are routing the 911 calls, or they're being used as validation engines for those LIS systems or LDBs. And the SI is really one of the most important parts of this next phase of next generation 911 as we start to prepare. So an SI is really a GIS data provisioning tool. And there are some misconceptions about an SI. An SI does not route 911 calls. Once your data is put into the SI, it cannot be modified. That's not where that happens. Now, an SI is a highly structured spatial database that's used for that provisioning. It can also be used as a validation engine to ensure that we don't have bad data across multiple jurisdictions, so that you and your neighbor aren't claiming ownership of the same subdivision or the same piece of property, the same address point, right? So it can identify where we have these areas where our data might bump into each other. And of course, no GIS data can enter the EZNet without going through the SI. It's the safety area, if you will. We need to submit it there before we can move on to the next phase. So it's really important we understand the spatial interface kind of provides us with that interface to from the 911 authority into the ECRF LVF. These components here, the ECRF and LVF, we're going to talk about those next. And maybe this would be a great place, Drew, to maybe mention the provisioning of data and the projection of data into WGS 84.
Absolutely. So this was a question that was asked at the top of the hour or at the beginning of the presentation is, are we going to address coordinate systems for local data as it pertains to NG911? Yes, and this is a very simple conversation, but it's one I want you to put a lot of thought into. So when you provision your data into the spatial interface, you can take your local data, the way that it's projected now, and throw it in there. That function, the SI, is going to reproject your data into WGS 84, right? So we know what's going to happen during that. We're going to introduce some error. It's very small, depending on where you fall on the spectrum. But what it also means is you are not going to have to worry about reprojecting your data locally prior to provisioning. So regardless of all right, so your data as it sits now can go in there. It's going to get reprojected. It's going to be distributed to LVF and ECRF, and you'll be able to take your data out of that system, I want to say in your local projection, and they come out in WGS 84 if you need to pull it out. you really aren't going to pull it out though. It's not a push up, pull down. You push up to support the functionality. What comes down would be quality assurance checks or error reporting, letting you know where the anomalies exist in your data for you to correct and then re-provision back in, right? Understand some of the QA/QC checks will be spatially related. So as your data transitions from your local datum, probably state plane, into WGS84, some stuff is going to move. Now, this is where it gets interesting. When you get those reports and you're working through the remediation components, it's going to look right in your data because nothing moved. So just to play around with it and prepare for that, you may want to reproject a copy of your local database into WGS84, see what changes occur, or work with a provider that has a validation solution that will pre-validate your data for you, let you know where to make the corrections, and then pushing it up, you won't get a lot of stuff out. It is recommended by NINA to pre-validate your data prior to provisioning to the SI, just to decrease the number of QA/QC checks that are reported out of the SI, because it'll be a lot to fix. It took me 2 years to correct my data against the QA/QC checks. So also think about, if you are a county and you are pulling data from your cities, you'll want to make sure that your county data and your city data is projected the same or aggregated before provisioning that into the SI. So that there are some quirks to work through. I'm happy to have those conversations with you to talk through it, because it can get a little detailed, but you don't have to reproject your local data into WGS84 prior to provisioning. The function SI itself will do that for you.
Right, right. You know, when we jump into these ECRF, LVF standards, you know, they do play different roles, right? You know, in the LVF environment, that's the location validation function. That's what's working against the list. We're pre-validating the static location of callers. It validates the specific location of a pre-verified location, you know, of a line, of a landline phone against the GIS data, so that it's ideally, you know, going to be something that's going to be exactly the same data that we're using inside the UCRF. So what the SI is doing is it's kind of being kind of the centralized repository that then provisions both of these systems with the identical data set, and make sure that the information that both are looking at are going to be the same. Now, an ECRF is a little bit more complicated, because what ECRF is doing is it says, you know, it's taking in a request, right? They have what they call an ERP. It's an emergency routing proxy. Now, a proxy itself is kind of a dumb, it's a question answer or question taker, right? It brings in the information, then it turns around and says, hey, where is this? It's kind of like when I drive with Drew and I say, where am I? So you have to tell me where I'm going. He's East Coast, I'm West Coast, it happens. So, you know, where do I send this call? So it's actually taking the information of the caller, whether that's, and like I said, the location of the caller could be coming in the form of a landline phone number associated with an address, which is then providing us with a specific location. But it also could be a lat-long coordinate that's coming from the device itself to tell us where that 911 caller is at. And so it determines the correct location of the caller against the active call data that as it's coming into the system. And so it's really doing kind of an on-the-fly spatial query to figure out, okay, this call needs to go to this PSAP. It's not saying it's you know, it's basically making sure that we're sending it to the right location, that we're not sending it to a neighboring jurisdiction. It's basically putting that pin on the map and then drilling down and saying, okay, this location falls into this jurisdictional boundary. It does validate this information against the same data. So ideally, you know, you're looking at the same roads, same center lines, you know, same address points, same jurisdictional boundaries and ESNs and so forth. So really kind of the key message here is that these don't come preloaded. This is your data being provisioned into these systems. I used this a while back in a presentation I did at the Colorado 911 Task Force. I love the slides. So, making this transition to NG911 is really about moving away from this legacy 911 network, which is the mystery machine. We don't know how things got there. Generally speaking, when we move into the i3 network, we're getting ourselves a new Mercedes wagon. And it is going to, the good news is the gang still fits, right? Scooby can still ride in the back. There's plenty of room for Velma and everything else, right? But ideally, we're not going to break down in front of nearly as many haunted mansions. There aren't going to be as many flat tires. We won't run out of gas, generally speaking. We're going to have a much smoother ride and a much more comfortable, move forward. When we think about that, though, we also had to put into perspective that GIS is going to be the fuel behind NG911. The quality of the data that we have is going to directly correlate to the efficiency of that engine. And so by moving away from the mystery machine and moving into this nice Mercedes wagon, we want to put in the highest grade fuel we possibly can get, because that's going to make the engine run cleaner. It's going to get us further with our gas mileage. It's ideally going to put our communication vehicle in the best position to have the best success of finding somebody during the middle of a 911 call.
Absolutely. Hey, John, we've got a great question on why don't we just use HERE or TomTom data? Those are accurate data sets that are somewhat authoritative.
Well, that's an interesting question. I would say that the problem we run into when we think about TomTom, Google, HERE data is that, generally speaking, they originate their data creation, right, by collecting data from the cities and counties, but then they're not necessarily updating that data every 3 days, right? In reality, the data that's being implemented into that system, they may go through and drive through an area in Southern California, updating data sometimes on a monthly basis, depending on where you're at in San Francisco, right? But that's not necessarily going to be the case in rural Wyoming or in, say, rural Colorado. They're not going through and updating that data on a frequently enough basis that we can rely on that to provide us a civic location for a 911 call. It's one of those situations where it might be quicker, but it's not better. The best quality data we can get in the world is going to come from the local agencies and the local authority for 911 and GIS.
Absolutely. And I'll tag on to that. If your locality currently does not have GIS data, it may be great to purchase a HERE data set or a TomTom data set to start and build on. I love this. We've got a rebuttal. Yeah, but if you pay them, they will respond. Look at Amazon, UPS, and Uber. Maybe think outside the box. I hear what you're saying. Sure, we could pay HERE enough to create and reach out consistently to the community for accurate GIS data. The problem is they're not the ones that are responsible for maintaining it or updating it. So as you have updates, that occurs locally, which means HERE data becomes a third party, right? So they're still going to be asking you to provide the update so that they can integrate it into their database to then just provide it back to you to plug into your public safety, to plug into your SI.
And it ain't cheap. And it ain't cheap.
Yeah, it's also better to have data directly from the authoritative source, which is locals. It's a great question, right? Because people will have that. Well, I can just purchase data from HERE and update it, a couple of times a year for 911. Yeah, but our data changes daily, right? Mm-hmm. Not a lot of people can afford to have somebody just kind of manage their data at that level, when it could be, more cost effective to use a local vendor as a data manager or manage the data yourself. So there's a bunch of different ways to look at it for sure.
Yeah. But we also had a really quick question in here too, that when will CAD software providers be required to synchronize their data designs?
Never.
Never. But it's a great point, because I do think that this is an important distinction that we have to put in place. CAD providers and CAD providers for some time have had, if they were integrating GIS into the way the tool functions, they would go through and have their own set of tools that would be used for validation. 9 times out of 10, what I've at least seen in the CAD environment has been the purpose of that tool is not necessarily to validate whether or not if your GIS data is good or bad. It's just to make sure that the attributes exist in order for them to be able to go through and create a proper route for the location or driving to a destination within your data set. So in other words, not having things like speed limits, stuff like that, or turn restrictions, or is it a dual carriageway or not? Those are the kind of things that are really important to the CAD provider, not necessarily whether or not if that road range is actually properly submitted into the system. They're not really worried about that component of it. They mainly want to make sure that the key information that's critical for their routing engine for getting from point A to point B will be able to be fulfilled, right? So, there are some great validation tools that different CAD companies have introduced over the years, but the expectation is that you may have to go through and create a schema around that CAD vendor, as well as the NG911 system, as well as your AVL provider. It's just part of that issue. But I will say that there's some great vendors out there like Datamark that have gone through and built solutions to go ahead and improve the data validation process, as well as being able to go through and push out that data to multiple schemas from a single data set. So there are some great ways to go through and approach that problem. And Dave, you got time later, maybe we can reconnect.
Yep, absolutely. All right, now let's talk about standards. This is the fun part of the conversation. Not really, but it's an important part of the conversation. So I will encourage all of you, if you are not familiar with the NG911 standard for the GIS data model, start familiarizing yourself with this. This document's about 108 pages. It's great nighttime reading because it'll knock you out super quick, right? But there's valuable information in here, but it requires thoughtful interpretation. So you can't take what you read as, this is going to sound really bad, but follow me. You can't take what you read as Bible. So when you see mandatory fields, when you see optional and conditional fields, do not think that you have to integrate all of these fields into your existing attribute data. You don't have to. We're going to talk through that in a second. Mandatory fields must be populated because they are mandatory. When you get to legacy fields, which can be conditional, and some of the optional fields, think about the granularity that they're asking for and determine if you have the capability or the resources to maintain that. Because it's one of those, while yes, you can build your attribute table to support all of the mandatory, which you have to, the conditional and optional fields, you also have to maintain it. Because some of this stuff gets really granular, like down to seat level. Seat level in a conference room that can change layout doesn't make a lot of sense.
Did you want to move to the next slide, Drew?
Yeah. It's a perfect time to go to the next slide because I think we actually show some of that here, right? So as you're going through this document, it provides examples like you see over here on the right. That's our attribute table where we're seeing ESN left, ESN right as conditional fields. You've got your county left, county right, state left, state right, extremely important as mandatory fields. You won't believe the number of data sets I look at that don't have a county field or a state field. And that's because we're in this box, and I quote box, of managing data for our city or our county, and we make the assumption that people know where we are. Of course they do if that data is shared within your locality, but as you push it out to others, they may not know that it's your county or your city or even your state. So those are some simple fields to integrate. And then you have optional, like neighborhood community left or neighborhood community right, postal left or postal right. Those are optional and are easy to maintain because they'll support incorporated or unincorporated municipalities within your county, which provide a further level of detail of understanding of the area that you're in. So if we look at how the document explains mandatory, conditional, and optional, mandatory is an attribute value that must be provided for the data field for each record. John, if you'll go back for me 1 second.
Oh, I'm sorry. I think we were moving on
You
to
can
the
actually
next
keep it there. No. Go ahead.
Okay.
I like it. So the conditional, if the attribute value exists, it must be provided. If not, leave it blank. That's where I'm going to tell you to use some flexibility. Understand what it's asking you for. If you have it provided, if you don't worry about it. And then optional, this is also where you have to provide that level of understanding for granularity, because you also have to maintain it. And then I love this last bullet that's here, that local policy may dictate that all data fields be included in the structure regardless of the data that exists. That's a great one. Here's where I like to think about mandatory, conditional, and optional. This is not a rewrite your entire data set, rewrite your attribute table to support NG911. Look at what you currently have in your database. Look at the attributes that you currently have. Connect to the fact that those attributes are currently supporting business practice. As you integrate the mandatory fields, pull in all of those. You may already have them. If you don't, pull them in. Same with conditional, same with optional. You don't want to scrap your data schema to support NG911 because you're going to break other systems that's currently using that data to operate. Also think how you can meet the required data set, like street name. Street name is a mandatory field, but it has to be spelled out. Or street type, sorry. Street type is a mandatory field that must be spelled out. Well, most CAD systems will not support that many characters. They'll only support 2 or 3. So you have it abbreviated in your current schema. Just add a street type field where you spell it out so that you have both. You have the abbreviation and you have it spelled out. That allows you to support existing business practice while preparing for NG911. Does that make sense? So be really thoughtful about how you approach this.
Yep, and we are going to talk a little bit more a little bit later, guys, about some of the, I guess you kind of call them sort of some tips and tricks, some recommendations that we have around, you know, how to identify kind of holes you might have in your data. I think one of the really great ones that is going to be in here is about communities, because there's some really interesting language in the NINA standard around communities, saying that they are conditional or optional, but then at the same time mandatory. So just be prepared for that.
Thoughtful consideration must be given when you read through these documents.
Yep.
The civic location data exchange format standard is the other one I want to point you guys to. This is going to identify how you should build or improve your attribute structure for your address points. So when we go to the next slide, it's going to immediately point out data parsing. Parsing is not generally practiced by most, right? It's taking the street name field where you have your house number, your street name, and your street type all condensed into one field or one attribute and splitting them out. That's data parsing. If it's not done, there are some processes I think that you can run in Esri. I think you can actually go out and find some scripts that'll run and parse your data for you. Do that. That is a requirement. If your data is not parsed, it's going to be impossible to validate that data to meet NG911 standards, right? The document also identifies the definitive set of core civic location data elements. We'll actually go through a couple of those. So really thinking about the street name, the address point, and street type. We'll talk about those. It's going to map a profile between the PIDA flow and the same NINA core civic location elements. We don't really talk about that a whole lot in this presentation, but if you have questions related to PIDA flow, please send them to John or I, and we'll get you the answers. And then we also want to map the civic location data elements corresponding to thoroughfares, landmarks, and postal addressing data. So this is telling us that in our addressing data, it can be landmark information. It can be non-mappable structures or non-mappable, sorry, what's the word I'm looking for? Like non-postal structures, right? So they don't receive mail and nobody lives there, but you can
Right.
put that in here, like a fire hydrant, a pumping station. If you have a pump house that has an address, that will be supported in the NG911 environment, and the CLDXF document walks you through how to build that out. Does that make sense? This is equally as important of a document, but gets down to that finer detail, like you will see on our next slide, identifying the 8 street name elements that are identified in CLDXF, like the pre-modifier, the pre-directional, pre-type separator, street name post type, street name post directional, and street name post modifier. I think if most of you guys are in an Esri shop, you've probably used the local government data model, which addresses most of these attributes. You may have to add 1 or 2, but the document defines what a pre-modifier is, like an alternate route. For alternate route 8, alternate would be that pre-modifier. A street name pre-directional makes sense, right? North, south, east, or west, like North Fairfax Drive. The pre-type avenue. So if you have an avenue A, avenue is your street name pre-type, not the street name pre-modifier. Does that make sense? And then we have the pre-type separator. I rarely see this, but I know everybody's a little different. So if you have a street that's Avenue of the Americas, of the is the pre-type separator. So avenue would be the street name pre-type, of the is the pre-type separator, and then Americas would actually be the street name as we continue to move down that list. And then the street name post type, if it's Avenue of the Americas Drive is the post type. This can be really confusing, guys. And then the post directional is the north, south, east, or west. If you have a Main Street South or Main Street, right? So you can have a North Main Street. That north is the pre-directional, but where the directional is after the street name is the post-directional type. And then the post modifier would be for trails or an extended. If you have a Main Street extended, that extended would be that post modifier.
So this is why you were saying you ought to buy a parsing tool to kind of help facilitate this for you.
Exactly. This is where I geek out as a data nerd, because I like solving these puzzles. But if you have questions about what's what, call me.
Yep.
Most of it's going to be easy, because I want to say most of us have just a street name and a street type, maybe a pre-directional or post-directional. The rare occasions are the pre-type separators, the post modifiers, the pre-name modifiers. Just don't beat your head against the wall. Give me a call. Let's share a screen. Let's talk through it. We'll figure it out together.
Let's jump into the next one.
Absolutely. So data parsing, again, as a continuation from the address points we just looked at to our address number prefix, the address number suffix. So there's 4 elements for parsing your addressing data. This is really focused on the house numbers. So the house number prefix can be alphanumeric, like if you have A118 North Main Street, that A is that number prefix. The street number is the location of the house as it falls on the road, right? 1213 North Main Street, that 1213. That address suffix, it can also be alphanumeric. If you have a half address, or if you have subaddressing, subaddressing actually is outside of this. So this is really as it relates to, the only time I've seen it is if you incorporate half addresses. So if you incorporate a half address, I really want to know why. And I really want to help you work through putting that in here. That becomes that address number suffix. And then what's optional as address in CLDXF is if you have milepost markers that may be given in place of an additional address number. I rarely see that, but it does happen on occasion. It's also why it's optional. You can also make that as a descriptor if you're not really sure where it goes. So if you have 1213 North Main Street, milepost 42, 42 would go in there as the address number suffix or in that optional field, or you just describe it in the descriptor field that you put into your attribute table. That's a harder one for me to identify because it happens so rarely. And then the next one's where it's going to get really important for you when we talk about subaddressing. So subaddressing as it relates to apartment buildings, strip malls, college campuses, commercial and industrial areas where you have a building at 456 Oak Street, but it's multiple buildings. So you have a single identifier for mailing, but you have different building identifiers, building A, B, C, or D. Right? So building A is 456A Oak Street. So that's a subaddress. You want to provide additional location information. So if you have different suites inside that building to identify different offices or different meeting rooms, that's where that would go. If it's multi-level, you have a place to put floor. If it's unit, you have that room or seat. This, guys, this is cool because you can do this. If you are going to go past unit, be really thoughtful on why.
Mm-hmm.
Schools are a little different because you can identify rooms as the high school math, high school social studies, computer lab, library. That's cool. Or if those rooms have numbers, they're unique identifiers. That's cool. Put it in there because you have it. This is one of those optional fields. But if they constantly change, it's going to require you to constantly keep this updated. So how easy is that going to be? What's your relationship with the property manager or the custodian or somebody who's familiar with changes that are occurring inside of the four walls because you've planned to seat level in cube 23 at seat 100? It's
right.
Cool that you can do it. How hard is it to maintain it? So really where I really want to encourage you guys to focus with subaddressing is building additional location information, floor and unit.
Mm-hmm.
And as you'll go ahead, John.
I was just going to say, you know, one of the big things that I know I've run into in some address elements has been, you know, if you go through and you find, like, say, for instance, like a mobile home park. Right, mobile home parks, historically, you have a single address, which is location of the mobile home park office. That one address is used over and over again, and you'll end up getting, you know, you don't have necessarily the breakdown of all the units. You have 50 units that are all stacked on one point. And so this is one of those really important things in sub-address elements for places like that. Apartment buildings, very similar. Being able to go through and identify, you know, the building or unit is key. And you know, can't stress that enough. If you guys can make sure you have that in there, it's important.
Absolutely. And this is a conversation I want to have with you guys because subaddressing is extremely important. And as you get into it, it will start making more sense. It could also be more confusing for you.
Yep.
All right, so let's move on to ECRF and LVF standard. This is a quick read. It's a quick document. It's definitely shorter than the data model or the parsing document or CLDXF. It identifies rules that your data needs to meet to pass or to function in ECRF LVF, like identifying no gaps or overlaps in your data. Provides examples of the types of questions you need to ask of your data, right? So it'll show you examples of what type of questions you need to ask to identify gaps or overlaps, or what type of discrepancies examples could come out of the SI. That's about all I can say about this document. I mean, that's really what its purpose is for. It's to make sure that the data that's being provided into the SI will pass and operate in ECRF and LVF, and it's identifying data validations, guys.
Mm-hmm.
Focus on the data model and CLDXF first, and then get to this one. And this one will make more sense and be a little easier for you to understand. and read through. And then we're gonna just briefly touch on several other standards I want to point you guys to. We're gonna move through this pretty quick. The additional data standard for NG911 includes building contact, building tenant information, right? A little more supplementary to the point location. Identify how valuable this is, and maybe something that you work on over time. You don't need to have this completed before you provision your data. Don't think that. But if you can make improvements toward this, do it. It will benefit you later, but you also have to maintain it. All right, the next one for me, John, is the site and structure address point. Focus on this one. It addresses point placement, multi-points, as John was talking about with our sub-addressing, additional impacts of data. And really, at the core of this is going to really just encourage you to be consistent with your points. Are you going address point on front door of structure or on center of structure? Be consistent through the database. If you're identifying multiple points for apartment buildings or strip malls, where do those points go? Do they sit on top of each other, or you distribute them across the footprint of the building and then stack them there?
And we will be covering some of this later too, right, Drew?
Absolutely. We've got some slides that show this for sure.
Yeah.
All right, and then we've got LVF consistency. Why do we validate? What's considered a valid location? Valid civic location and matching one-to-one and street name aliases. Read this document because of that last point, street name aliases. Those tables will be supported in NextGen 911. If you already have them, great. If you don't have them, it's something that you can create. So when we think of a street name alias, it's the changing of North Main Street to St. Bernard Road, right? The current name is St. Bernard Road, but it was formerly known as North Main Street. That alias table will connect that together so that it will route correctly in LVF. Eventually it will go away, but it's good to maintain that. And then our next document I want to point you guys to is the E911 data exchange and GIS mapping. Identifies the number of characters for each field, USPS postal standards for pre and post directional, versions of formats for MSAG data exchange, versions of wireless data exchange, and really kind of addresses the GIS data model version 2.0 with required and optional layers. This is the original, right? And then they updated it with the NG911 data model.
Yes. Yep.
Yeah. So if you want to see it, is it related to really addressing more legacy environment and preparedness for E911? This document, I think, is the one that also addresses the 98% synchronization, which is telling you to have a 98% match of your GIS data to your MSAG and ALI, just the tables. It doesn't address spatial accuracy for that 98%, which is why we really encourage, and John encouraged you guys to think beyond 98%, which is also why the validations that are required for NextGen 911 don't just look at tables. They look at point location and point placement. All right, John. And then the synchronization. This is an older one. This is, it's a great document because this one also really references GIS to MSAG and ALI and talking about synchronization. It was also identified as not a recommendation back in 2009, but we've gotten away from it over the years by not synchronizing our GIS to our MSAG or our GIS to our ALI. We really just, what I've seen is people just really update their MSAG data with new GIS data, but never compare the two together on a consistent basis. That's not to say you're not doing it once a year or once every other year. It's something that we've gotten away from. But if you want to know where that started, it started in this document.
You know, I just to volunteer something here, Drew. I think another part of it too is, at least what I have found, is that people have a trust factor in one or the other. They trust their ALI database because it's being maintained by a telecommunication provider, it gives them great addresses, or they absolutely depend on their MSAG because this is something that's maintained in-house and they feel it's totally reliable.
Yeah,
but it costs them money to get an ALI data transfer from the carrier. So they'd rather use their MSAG over their alley because they're afraid it's going to cost them money to go through and use that.
That's a great point.
Work on tight budgets. So
great point, John. But that leads us into actually how do we have a conversation? How do we start talking about Next Gen 911 locally? What are some things we need to think about?
Right. Well, and you know, guys, I might fly through some of this here real quick because I know we're going to be running out of time if I don't talk fast. So strap in. Are you ready?
Let's go.
So when we think about the public safety data supply chain, and I've actually given this presentation in Colorado in the past, as well as up in Montana, but you know what we're really talking about is, you know, sort of this concept of we have a data supplier, manufacturer, distributor, retailers. This is the way we think today about kind of, you know, how a data supply chain might work. But who is our data supplier, right? Our data supplier might actually be, you know, the building permit officer. It might be the surveyor. You know, they might be the data suppliers are giving us new information. Then it's our responsibility as GIS people then manufacture that data and then distribute it through ArcGIS Online or some other means, you know, that we're sharing that data out with others, and then it's being used by somebody else. What we don't think about on the data supply chain is that this is a cyclical process, right? We're going to be pushing data up into the system as our deliverable, our product, but yet we're going to get information that's going to come back through this process that's going to tell us if we have bad validation checks that have happened within the SI. And so we're going to have to go through and resolve those issues and filter those back up through the process. So it's particularly important when we think about our data supply chain that we understand that this could be happening at a local level, but it could also be happening at a regional or multi-jurisdictional setting, that we're trying to develop this kind of master data approach to pushing data into that system and pulling it back out. So how do we get there? Well, the first thing we need to do is we need to develop a transition plan. We need to identify who our stakeholders are. We need to gather that information, start to assess our own data quality, do some gap analysis, and determine if there's any kind of deficiencies in our data or in our workflow that we need to try and address, and then move on to that next step, which is starting to go through that process of remediation and resolving some of these issues. So what do I mean by identifying stakeholders? Well, the end goal is that we need to have this kind of cohesive cross collaboration, you know, with key stakeholders that are in the public safety sphere. But if we think about where that public safety sphere is today, right, we think about 911, police, fire, EMS, so they're somehow another kind of siloed away from us as key stakeholders in the public safety realm. What we've probably heard today is we're all in it, right? We're all in it. It doesn't matter if you're in the IT department, GIS, planning, public works, the assessors department, we're all public safety stakeholders. You know, we all have an invested component of this, right? So, you know, if we start thinking about, you know, how we move forward, what we really need to understand is we're no longer siloed. We had a customer actually a while back that was in California, 1.3 million people that lived in this one particular county, and they were trying to go through and do an address cleanup project. And what we found was that multiple departments within the agency had actually gone through the process of developing their own database standard for addressing. In fact, there were something like 5 different authoritative address data sets that were in this system. So when we started and we really started to evaluate the number of address points they had, well, we came up with about 250,000 address points. When we went through and we started to break down all those silos and start to compare all the different authoritative address points that we had, we actually were able to go through and identify that we had somewhere around 70,000 kind of questionable addresses that were in the system, and about 130,000 new addresses were created because of all of those sub-address elements we had not identified, because of, you know, units within apartment buildings, mobile home parks, you know, large buildings and structures and so forth with multiple suites. So we identified all these other addresses, and so it actually took a lot of work to kind of gather all these people together to kind of come up with that one authoritative data set. And like I said, we were trying to come up with this plan of rolling out a master data set that everybody used the same standard, right? And so that was one of those kind of examples of identifying those key stakeholders. The other part that was important about that information gathering is understanding who was actually the authoritative owner of that data, that was being basically the ultimate decision maker about the data itself. How should it be populated? How should it be, submitted into the system, versus who's a data steward, right? In many cases, I've seen it where the addressing authority might reside from within the assessor's department, but the data steward's responsibility is going to be somebody that's in the GIS department to then put in this information that's being loaded by community development or some other division. So the data steward is the expert in charge of ensuring the data quality is actual good business data to the corresponding metadata. And of course, they're performing the regular data quality checks and updates to the system. So there's a difference between being the owner of the data and being the addressing authority versus being the data steward that's actually putting this information into the system. They're all stakeholders. As part of that information gathering, we understand kind of everybody's roles and responsibilities. We start to map out kind of the workflows and the business processes we use to go into the addressing lifecycle, the road centerline lifecycle. We want to go through and understand, where does the request come from? How is it then assigned? Where does it all, and how is that a cyclical process? And how does it tie into GIS? Is that data available? What's the quality of the information? What's the schema changes we need to have? Drew made some great points about, we don't necessarily maintain data in current systems, maybe the way that NENA requires us to, but just by simply adding the field for streets and having it spelled out can be a huge time saver for us when it comes to trying to put this information forward in an NG911 environment. So what do I mean by data quality? Well, when we talk about data quality, we're really talking about kind of 5 key components, right? Number one, is the data available? Does it exist? That's a simple question to be able to go through and ask. The next question, though, is to say, is it complete? We may have certain components of that stakeholder community that maybe only maintain a small portion of our overall county or jurisdictional responsibility for public safety. So they may only have 75% of what we need, and we still need to find that other 25%. So is the data complete? The next question we need to be able to ask is whether or not is it accurate. I've got a friend of mine that talks about the difference between, the difference between accuracy and oh shoot, what's the word I'm thinking of, Drew? Precision, accuracy versus precision, right? Is it accurate to the real world as it exists out there, or is it, kind of generally in the right area where it needs to be? So accuracy versus precision. And of course, timeliness. And this is one of the really important ones. We kind of talked about this earlier. The way that we've maintained and thought about data in timeliness fashions in the past, when I first started, was, I got my last GIS mapping update when I did my install on my CAD system, right? That could have been 3 years ago. Timeliness, and particularly as it relates to this requirement for NG911 and this 3-day turnaround, we want to make sure that we can get this data as frequently as necessary, like whether that's on a weekly, monthly, daily basis, right? We want to be able to have it. And then, of course, the big one, and our good friend Brian Brady always talks about this one, and that is consistency, right? Being able to make sure that I'm always going to get the data in the correct schema all the time. Is it going to be consistent? Every time it's delivered to me, am I always going to get the right data, or is somebody going to go through and start tweaking with their system because I got a new ERP system and all of a sudden now I'm not getting all the fields I require, right? That can break things for me. So I want to make sure I'm going to be getting this data delivered to me in a consistent manner. The next thing we need to go through is really talking about that validation process. And validations can be overwhelming because, especially when we start talking about all the different address point requirements, road centerline requirements, community and boundary type things, we really need to understand that this is different than a CAD to validation that we might do for checking GIS data. NG911 is all about precision and truly mapping out what's real world, right? And so we really need to be able to address all those components, right? The data completeness, what type of anomalies we're running into. Can we synchronize against our MSEG and our ALI? And does it still represent? Because there is going to be a time, by the way, before we can transition to NG911 where we will have to maintain 2 different systems. And so we want to make sure that the GIS data is being consistent, but we also want to make sure that it's synchronized to our MSAG and our ALI that exists out there today, because there will be a transition period that we'll have to go through at some point before we can make that move into an NG911 environment. And then how easy is it going to be for us to be able to maintain that? So the validations, we're going to spend a lot more time on this towards the end of this presentation today, but I really want to emphasize that validations do not get overwhelmed. There are tools, resources, and companies like ours that basically can help you kind of address the validation challenges. Determining deficiencies. When we talk about determining deficiencies, we are talking about kind of identifying those kind of workflows and business processes. Now, we've already gone through and talked about, all of these different NINA documents, but I just want to reiterate those for you so you got a chance to see them again. Identifying challenges within your workflow, it could be something that's happening within your own department, but it could also be happening within a department that's outside of your control, where it's just a matter that they haven't actually gone through and they're not consistent in their workflow. You might have, multiple building permit people that are working in the department, but maybe one of them doesn't necessarily put in all the right information in the proper fields, right? How do we identify that as a problem? Is there a business process, a slowdown that happens because let's say, for instance, somebody's issued a building permit, but it's not physically considered to be an address that can be addressed until it's actually suitable for the structure to be lived in. Yet at the same time, we have construction personnel that are going out there working on that site every single day. So is there a hole in our business process that's going to prevent us from being able to go through and populate data that needs to go into 911? And of course, we want to be able to make sure we're maintaining our existing GIS data, and we want to make sure that it does correspond to that legacy data that we're dealing with in the 911 environment, the MSAC and the ALI. So these are really important, understanding those deficiencies. If I start making changes to the GIS data, how can I reflect that that's going into the old legacy system as well? So that way, even if we are not making the transition today to NG911, we're still benefiting from the improvement of the quality of that data. Now, the last piece of this really is coming into the data maintenance mode, right? And how do we integrate this new process into our workflow? And then being able to run that data remediation process so that we can kind of meet or exceed those NINA standards, because it's never necessarily complete. We're always going to have to continue to maintain it. And I talked about this earlier. We kind of start off here and we have this high level of effort that has to be involved with cleaning up our street center lines and our address points. But over time, this becomes much easier, right? Because now instead of having to deal with 500 street segments that need to be changed, we're only dealing with 5 in a month, right? Ideally, that's where we're trying to get to. But it does require that we have kind of a workflow behind it. So we need to be able to run information through a validation engine, right? Once we've run that data through the validation engine, we need to pull back. What do we need to go through and change in order to identify where those problems are at? We could go through, we review and make those changes. We create a new package of data and we run it back through the disk system all over again. Eventually, you're going to be able to do this, almost in an automated fashion. But initially, it might seem like it's a really heavy lift. So just understand that when you're talking about kind of building out this transition plans, these are all the things we need to really think about to kind of make it through that process.
John, absolutely. And I'll tell you, I really kind of want to dig deeper into that maintenance aspect for you just a little bit, especially as it relates to validations, because for me, validating my data is now a part of my maintenance process, and I use it to identify issues in my data. So I really want to reiterate something that you spoke to earlier as it relates to validations. We're now looking at CAD validations versus NG911 because there is a difference. Whereas both somewhat sort of look at data completeness, it's to a next level with NG911. We're trying to identify all of the anomalies, and I'm being very, very strategic here, guys. We don't want to call them errors, right? Why, yes, sure, errors exist in our data. We get it, we know that. But we really refer to it as an anomaly because for NG911, you can have an acceptable anomaly, an acceptable error. A house that maybe doesn't fall on the right side of the road, a duplicate address point that may actually be duplicated in reality. Because we are reflecting reality, there is no way that we can build rules to represent reality because we're all a little different. But we do want to identify all of the anomalies that exist in our data so that we can synchronize and maintain and improve our data, even though it may have acceptable anomalies, right? And where we want to start is really building the value and validating our data, right? So the purpose of performing data validations is to ensure that the maintenance of our data is maintained at the highest level of accuracy possible for completeness and data synchronization. And really where that comes from is the NG911 data model document when it tells us how our GIS data is being used to support geospatial call routing. So I know that if I have here I'm gonna say it, you're gonna cane me for this, an error or an unacceptable anomaly in my data, it can affect geospatial call routing, which means I'm negatively impacting where that call is routed to, so where that call is going. Meaning now my GIS data is impacting the time it takes to accurately send and receive that call, as well as identify a location of that caller potentially. That is new for us. I'm now telling you that your GIS data has a critical function and the life-saving capacity of 911. Let that sink in for a second. We've never been put in that situation before, right? That in of itself is overwhelming, but it's not impossible when we think about this methodically and we take a very proactive approach to validating our data, which means we now need to look at things that exist beyond the attribute table. So where with our data attribution and validating our tabular data, we're going to compare our GIS attribute table to our MSAG and our attribute table to our ALI databases to make sure that there's a one-to-one. We want to make sure that the road ranges I have in my MSAG also exist in GIS, and the address points that I have in my ALI I also have represented in GIS. But we need to take it to another level. So not only do we need to verify that the tables are correct and synchronized, we want to make sure that there's a consistency to the spatial aspect of our data. We talked about it with our address points. I'm going to show you some examples here in a little bit. Our road center lines. We want to make sure that we're looking at and being very methodical about real versus theoretical road ranges, or the spelling of our roads, all caps, mixed case, all lowercase. We have some consistency in how we're tracking our abbreviations, AVE or AV, RD, DR, making sure they don't get flipped. We want to check our polygons. We want to make sure that we're not using multi-part polygons. We don't have any topology errors, and I'm going to show you some here in a little bit. Are you using snap points when you're creating your data, whether it's your polygons or your polylines? So topology is going to play a really big important in this as well. So when we think about validating our data, we have to think about reality, and does our data represent reality pretty well? I mean, beyond 98% well as represent what's currently used for our legacy 911 systems. All right, so we want to start with our address points because they are the most important, most precise resource that we have. But as you can see here, we have some discrepancies and some anomalies where some of our address points are sitting on the center of structure. We have some that are sitting out at the road. I have seen addressing data sets where I need to identify the points that are on the curb. Are they really home addresses, or are they fire hydrants or street signs or light poles or water valves? Am I mixing my point data? If I am, I need to identify that so that I can separate them so that my address point layer is really just for my address points. And I have consistency with placement, right? Which is going to impact us when we don't have imagery as a background, because we're driving people to these locations. We also want to make sure that we're identifying sub-addressing and substructures, and I've actually got a better image for you there. But this can also include non-addressed dispatchable locations like I was referring to earlier, like pump houses, electric substations. Make sure that they're described well, and that if there's a structure for that, that it sits on the center of structure. What's going to be new to this argument with address points are access points. There's a requirement for Kentucky that not only are you providing non-addressed dispatchable locations, landmarks, and address points, that you also provide an access point layer for areas that are in the rural parts of the county where you have that half-mile long driveway. An access point will be placed at the road.
Yeah.
Now, when you're placing your points, there's some consistency to look at here and some different methodologies. Are you geocoding all of your address points so that they geocode to the road center line and fall within the road range? That's cool. Is it as accurate as it can be? Are you placing a point just on a site? Is there any methodology to it or any understanding of where you're placing that point? Are you parcel placing your points, which is super easy, but it's not as precise and accurate. It's accurate because we're identifying a unique location for a place, but it's not real precise, right? When you get down to the structure placement, you're starting to integrate some precision, and even more precise is if you put your points at the front door of the structure. A bit harder to do. It's doable. It needs to be consistent. Don't flip-flop center of structure and front door of structure, right? It gets confusing. Be consistent with it. And then you just heard me talk about property access points. Be thoughtful about when you use those, right? And in a subdivision where you have 50 parcels, 50 homes, and all of the homes sit 20 feet off of the road, you may not need an access point. But as you get out further to the county and you have that 200-meter driveway, an access point will be helpful for your responders.
I think this next one is also really key when we start talking through these different methodologies. Geocoding a range, this is something I see very commonly in a lot of pretty well-established GIS data sets, to be honest with you, because they started off in the very beginning and said, hey, it's going to be this is the 100 to the 199 address block. And so there were all these potential road ranges that were in there. As time has gone on, however, and new structures were built in that subdivision, there are no more additional parcels that can be added maybe at the end of the street. And where there might be spots that can be added, they could be incorporated into a proper road range. So there are advantages and disadvantages to using either actual ranges versus potential ranges. And it really comes down to location information. So it's very important to kind of think about this one as sort of a methodology preference. There are advantages and disadvantages to both, but it all comes down to what do you already have and how can you best reflect reality. And it may be that currently today you have a complete road range with the potential range that's in there. But understand, when you look at it from a geocoded standpoint, it's going to cluster all of these address points in the center of that road versus probably representing the more accurate location where they might fall along the line.
Right.
Partial placement on centroid, Drew, you talked about this earlier. This is really easy to do. In fact, for most of us, I would venture to guess that, having a partial centroid, for your data is not uncommon, right? We probably all have something similar to this. And like you said, once we start moving into more rural areas, all of a sudden, the larger the parcels get, the less consistent they are with being able to go ahead and actually hit the structure. And so, if you don't have this today, this is a great place to start. And then kind of move through that methodology from going from, a partial centroid to then partial placement to make sure that you're kind of meeting that ongoing standard you hope to achieve. Very easy to automate this process. And it can be something that can be fairly easy to kind of, join, to corresponding parcels and parcel and polygon type searches. But there are some disadvantages. And of course, that's not going to be very accurate, which is going to require you to go through this step of the process, right? Which is address point placement. And we've already talked through this. I don't want to beat this one to death, but the most common one we see out there in the world is to build them on top of the structures, locating them onto the structures. Very rarely do we see an entrance or egress type structure point. Access points are, generally speaking, I think I found that most of the time in very rural areas, especially they're going to have multiple structures at the end of the driveway. So you got the house, the barn, the chicken coop, whatever else. You know, there's a lot of things that go into those scenarios. So the development of access points is not necessarily as high a structure, it's high a priority as structure points are.
No.
I know you want to talk about this one, Drew.
I do. I love talking about sub-addressing. As we've mentioned, primarily found in colleges, universities, military installations, shopping malls or shopping centers, strip malls, apartments, and condominiums. Most of us have at least a set of apartments in our localities, right? We want to be really methodical with how we identify address points for those buildings. Predominantly, you see it just as one address point, right? Because it's the mailing address for the building. Well, we want to incorporate that in our attribute table to provide a sub-name field so that we can start tracking the sub-addressed units. Now, you may currently be doing that now in a label field or even in the addressing field where you are tracking that alphanumeric value 527A. If you're doing that, that's great. You're halfway there, but what we want you to do is separate that A from that address number field and put it in its own field in your attribute table identified as subname. And now we want to distribute the points on the building as best as we can, right? We just want to show that there's more than one habitable structure or unit to the building. This gets more complicated the more levels we have, right? So if you have an apartment building that's 5 floors, you may have a subname that references floor, like 100, 200, 300, 400, 500. That gives you that elevation component. But if you're using A's, B's, and C's, it can be a little more difficult. Don't worry too much about that when you're setting this up. Just think about how you can uniquely identify all of the units in that building and how you're going to distribute those points across the footprint of the building to show that. Whether it's an apartment building, colleges and universities and military installations operate very much the same way, and that most of them don't have address numbers for buildings. They're identified using names, like structure names. So this creates a great opportunity to have conversations with leaders at the college or leaders at a military base to start establishing some, we'll call it USPS standardized addressing for their buildings, because it improves public safety response. It also improves location identification for callers that call and they don't know what building they're in or even know what street they're on, because we typically don't use regular addressing methodologies for universities and military installations. That is a change that's happening though. Yep. And now topology.
Or I think one of the other things we run into a lot of times is street center lines. And you know, I think that the most important thing, and Drew talked about this earlier, you know, data topology is usually pretty easy to identify, right? We have self-intersecting roads like what you see here, you know, in this image. You know, that's a big no-no, right? We don't have proper breaks in the road center line at boundaries. And remember, boundaries are more than just saying like my county boundary or my city boundary. It's my emergency service zone boundaries. It's a community boundary. We need breaks in all of those places along in the way that the NENA structure is kind of developed. We need to remove any kind of duplicate street center lines, and we need to correct those address ranges that we might have. You know, it's not uncommon that we see an overshoot or an undershoot on a street center line, and those are fairly easy to resolve. But one of the things that we do want to make mention of is that, you know, there are attributes in NG 911 that may not exist in your current data set. And one of those examples might be the parity left and right, the county left and right. Drew talked about this earlier, the state or county left or right. Incorporated versus unincorporated communities, you know, an ESN for a left or a right, right? And the ESNs or ESZs are emergency service zones. I don't need to throw any more acronyms. I think I'm going to make people dizzy if I keep throwing acronyms down, Drew. So we want to show you some examples here. And Drew, this is a great example of, a road center line address point where we have a duplicate, and it's not that it's an error necessarily in the address point itself, but physically the range that it's associated with is located in two different places.
Right.
Right. So this is definitely one of those things we run into a lot. And there should only be one 115 Main Street in the system. If there's not, we've got a problem. We need to start resolving that through directional issues and sub or prefixes and other things. Do you want to go through this one?
Yeah, absolutely. So the other place where we see inconsistencies is in our attribute table, right? So you can see that left from, left to, they should go high to low, and sometimes they get reversed where it should go low to high, and we see them get reversed to be high to low. We need to identify, is that an attribution error or is it a digitizing error? In this case, I'm going to say that this is an attribution error. We just need to re-edit the attribute to show 2000 is left from and 2998 to. The problem with these, and John, I think you can flip to the next one. It's going to be similar. The problem with these types of unintended discrepancies is they're really hard for us to identify by looking at just the data attribution, right? Because these are spatial, and they're spatial in nature because they're easier to identify spatially, but it is an attribution problem. Here we have an overlap in our address ranges, which John just showed you, right? We have 100 to 115, and then we go 113 to 130. There's an overlap with 113, 114, and 115. That's an easy correction. We also have a digitizing error where we have two roads that are digitized into each other that can create this type of anomaly if we're looking at fishbones.
Right.
Because it's going to create a fishbone from each point to every part on the road that it maps to. Right. These are really fun to look at, right? Because we immediately know there's a problem if you're utilizing fishbones in your validation result. How do you fix it is where you start diving deeper into the data, which is going to allow you to become more comfortable and confident with your data. Understanding actually what's going on at the data level.
Yeah, and I mean, when you see something like this pop up when you've done a fishbone analysis, it's an eye opener, because all of a sudden you're like, oh, I could totally see it. I couldn't see it before, but all of a sudden somebody shines a light on it, and it's pretty obvious, right?
Absolutely.
I think this is another one of those situations, and we're going to talk about a few of these different kinds of examples, but these unintended discrepancies where we might have a range that is overlapping in ranges. These are some of those exceptions that Drew talked about, right? Because in reality, it looks to me like the driveway for this structure that's out here in the corner, it does actually probably exist off the same driveway that this house does. Maybe this house was built first, whatever it might have been, but its location along this street segment from a geometry standpoint, from a topology standpoint, should be not behind this one, but in front of it, kind of thing. So long story short, these are simple fixes, right? We just create exceptions to these kind of misordered addresses along a street center line. It's not necessarily truly an error, but identified as an anomaly.
Absolutely.
And we did talk a little bit about fishbone analysis. Again, this is really handy to be able to go through and be able to pull these up. A fishbone analysis should really look like this, right? Literally, a bones kind of hang off the backbone of that street center line right there, evenly spaced, actually not crossing one another, but having the ability to go through and see when I've created an error where an error might exist, or where I may have address points that aren't associated with my physical street center line that's by my structure. These are great things to be able to go through and identify and quickly recognize that, hey, I've got something kind of skewed here. I wonder if I need to go through and maybe make an adjustment in that street segment, or change maybe it needs to be split somewhere. I don't necessarily need to go ask that person to change their address, but I need to recognize that I have some sort of a flaw here in the way that data was originally created in the system. When we go through, we talk about boundary issues. You know, we did a presentation here recently in California. We called it the it's the biggest bull in a china shop. You know, boundary issues are major problems because it doesn't just involve your location. It actually involves neighboring jurisdictions. And it needs to be maintained. It's a required data layer for NG911. But emergency service zone boundaries, or ESNs and ESCs, these are in addition to like provisioning boundaries and community boundaries, are really important because this tells us where we're going to go through and place that 911 caller. We cannot have any gaps, or overlaps between these boundaries, and we need to be very consistent about kind of how these are maintained. There's all kinds of kind of unintended topology errors that happen within this environment as well, because for some reason, maybe there was an annexation of land or something along those lines. Maybe there was a sale of property which then adjusted the property line, so now it somehow or another falls into the neighboring jurisdiction. There's all kinds of things that can happen that can adjust boundaries. And like I said, not just county boundaries or city boundaries, but unincorporated areas and community boundaries and things like that can also play into this. So we need to be able to go through and look for these gaps and overlaps in the data. So here's a great example I had from Montana. This is a PSAP boundary that was created. On one side, you've got Missoula. On the other side, you've got Powell. But there is a site structure that's here that's basically a location off of Woodworth Road, but it's accessible from Powell, but it resides within the county responsibility of Montana, of Missoula. So what we need to kind of take into account when we're looking at this is that we're working with our neighbors, we're working with the other communities that are around us. When we identify things like this, here's another great example of how we can identify an exception to certain types of anomalies that are in the system, and we can improve the facilitation and communication that we have back and forth with our neighbors. The purpose of a 911 community, right? It's, in the old NG or E911 environment, legacy 911 environment, we talked about this idea of an ESN. These are associated with neighborhoods or communities. Those eventually became what we call ESZs, emergency service zones. But now we have to deal with fire, law, medical response areas, and how those all overlay with one another. And in some ways, they do kind of resemble political boundaries, but they're not necessarily coincident, because we may have say like a volunteer fire department that actually provides services outside of our jurisdictional boundary to a neighboring community. So we need to be able to identify that and share that with our neighbor so they know who the right response area might be. Another one I see in a lot of rural areas is like EMS services for ambulances, because they may require to call somebody in from outside the county to provide EMS services to somewhere that's outside of the local area that the main sheriff's office is in, that sort of thing. One of the things I think is really interesting, we talked about this for just briefly, but incorporated municipalities have to be mapped out. They are required inside of the fields for NG911. In addition to incorporated municipalities being documented for, as a community name, what it basically says inside the NENA document is that any coincident unincorporated areas also need to be mapped out as required in the data set. So you are not required to provide unincorporated areas, but then you are. It's in the same language. So what was the thoughtful consideration? Is that what you said, Drew? Thoughtful consideration? Those are examples of thoughtful considerations we need to do when we think about things like incorporated or unincorporated boundaries for communities. And these are different than those postal routes, right? We need to identify those in a different way. So, and I know we're running out of time. We only got a few more slides left. So yeah, so this is where we talked about the unincorporated areas need to be mapped. It claims it's an optional data set, but it really isn't. Here's a great example of unincorporated communities that we had in I believe it was San Diego County. So they need to be able to be that information needs to be able to be put in an engine requirement because that also correlates to who's going to be responding to North County Metro versus, you know, the folks in North Mountain. Oh, wow. We blazed through that faster than I thought. Should we go back a slide? So let's take a look. Do we have any questions that have come in from the panel yet?
We have not. We've actually done a really good job of addressing questions as they come in.
That's good. That's
which
good.
is great.
Well, let's jump into our final thoughts here.
Absolutely. So I think one of the most important things for me, John, to remember is that moving into this NG911 world, GIS is mission critical and is a life-saving asset to 911, which is forcing GIS professionals into a space that they haven't been in before. Right. So we need to acknowledge that, and we really need to accept it so that we can figure out what that really means for us. John and I have talked through a few things here of what it means. But if you want some more information about it or more detail, you just want to talk to it, please do not hesitate to give us a call. We also needed to really define and understand our data supply chain so that we can mitigate risk. And a lot of the ways we're going to do that is creating stakeholder engagement and participation. So communication through this process is imperative because you cannot execute NG911 in a silo. It's not going to work. There are too many players that are involved in the decision-making process that really affect that data supply chain. So you want to make sure that you're all on the same page. The next part of that is ensuring that your data is authoritative. If you are the data owner or you're the borrower, can you ensure that the data that you're receiving from another entity is authoritative? Do you know how often it's updated? How often are you getting the updates? Right, that stakeholder engagement and participation is really going to affect that. And then you want to work towards defining new workflows or redefining existing workflows and processes as you move forward. So does your current workflow support the recommended 3 business day response to errors? That is something that's very new, that is extremely new for GIS professionals because we've never been in this box of having a time limit to correcting our data. Well, this one's important and it requires you to think about it. I think John mentioned this. While it's a requirement, I do an entire presentation on how do you enforce it. It's a good question. You're telling me it's a requirement, but is the 3 business day police going to show up if it's day 4? Not really, but it is important to acknowledge that a lack in addressing anomalies out of the core services environment could affect the next call. Like a call made within that 3 business days to the same place could have a different outcome. And so we're now able to track responsibility. And that's significant and it's important to understand.
Yep.
And then sorry, go ahead, John.
I was just going to say, you know, when I put in here about the agreements, you know, the idea of a mutual understanding or a mutual aid agreement and things like that, these are agreements that just basically lock down that kind of that stakeholder engagement, right? If you come to an agreement with a neighboring jurisdiction that they are going to relinquish control of XYZ address that's, you know, inside of their jurisdiction, but they're going to have you responding to that area, it needs to be documented. You know, up to this point, public safety, a lot of times it's kind of been kind of a, you know, a handshake or just an unspoken type thing. And, you know, we need to get these things documented because ultimately there is ownership and responsibility tied in to managing the data for that area. And, you know, there needs to be something that's sort of a paper trail because unfortunately, like I said, up to this point, we haven't had that requirement. And I think it's really important to kind of have that sort of, you know, mutual understanding amongst your neighbors with one another, sharing your data with that jurisdiction. You know, maybe you don't have a requirement within your CAD environment to go through and have the entire neighboring jurisdiction's data set, But wouldn't it be nice if you could go through and cut out a 3-mile, 5-mile buffer around your area and collect that data, so that way at least you've got some supporting area to identify with your neighbor, and have an agreement that you're going to share your information with them as well. So I think it's really important to kind of have this stuff very well documented if you can get it.
Absolutely.
Yeah. And I think the last one, technology and support, like we talked about, we want to build in processes and workflows and simplify that process. We've got a lot of great tools we can share with you and show you, but we're not here to go ahead and give you a dog and pony show and try and convince you to buy our solution. We'd love to come back and talk about that at a different time or engage with you individually. But there's some really great resources out there for folks who want to get moving in this path and want to go this direction. So feel free to reach out and start doing a little bit of investigating. We'd love to share that with you. So kind of on my final thoughts, and you hit the nail on the head here earlier, talking about collaboration. It's important to understand that you are not alone. Data is not developed inside of a vacuum. So, focus on that collaboration aspect and building out sort of your transition plan, like we talked about. Education, there are a ton, as you saw today, there are a ton of NG911 standards, and these things are evolving, right? There are existing working groups within NENA that are available to you right now today that you can go join and just listen to the new information that's being kind of put forth about how they need to adjust some of these standards and things that need to be done to go ahead and quantify and change with regards to sub-address elements and other things, right? So get involved in some of these working groups and stay engaged around NG911. Continue to learn more about what's happening. Advocacy, I think, is another big thing that we really hold dear at Datamark. In essence, you are your agency's best spokesperson, right? You are the person that's going to be helping us implement this. So what you do today to improve your GIS data accuracy it truly has an immediate impact, because that data is what's going to be used inside their current public safety CAD systems. It's going to be used inside their AVL products. Do not think of this as being something, well, if I can do all this work to try and build it and nobody's going to use it for another 2 years before we have an active solution. That's not true, right? The improvements you make today in the data and the data quality that you provide is going to have a direct and immediate impact on improving the life-saving quality of the data that's being used. So leverage that. And I think, of course, the last thing is that local GIS authorities will play a huge role, a vital role, in implementing and maintaining NG911 moving forward. NG911 starts with us. So I did see that we've got a question that came in, and we are right here at the end of our time. So what was our question?
It's not a question. It's more of an acknowledgement of the amount of information that we provided as being extremely helpful, and an appreciation to the message that we're showing about the GIS as it relates to public safety, and our commitment to making sure that this education, this information gets out. Really appreciate that. This is something that John and I both are extremely passionate about. There is a lot to cover. You have to imagine, we only scratched the surface of a ton of different topics that we can go deeper into. So I'll encourage you, if you want more information or just want to have a deeper conversation about anything that we've discussed today, please do not hesitate to reach out and let us know. We're happy to have that conversation.
Yeah, I will throw out one more thing, and I think it's really important for folks to understand, and that is that there is a lot of potential funding opportunities that are kind of coming down the pipeline right now, both from a federal level as well as at a state local level, for funding getting this work done for NG911. So start looking around. I think what you'd find, is that there's going to be a lot of new funding available for these projects, which is going to really help us move things forward in the NG911 space. And with any luck, you guys can be the beneficiaries of some of that. And hopefully we can help you work through those processes.
Absolutely. So just as a heads up, guys, I threw my contact information into the chat. If you want to go and grab that, please do. Shoot me a message, shoot me an email, give me a call. I'll pick up. Let's see what we can help you guys with. We've got a ton more. We've got a ton of content that's educational that we can point you to that's on our YouTube channel. Or again, as I stated, if there's something just very specific to sub-addressing, to standards, to getting the conversation started where you need some help, happy to help you.
Yep.
All right, Rich, and I think that wraps it up for John and I.
Yeah. Well, that was amazing, guys. Thank you so much. Yeah, it's contact information for Drew is in the chat if anybody wants to contact them. And we're going to take a break here for about an hour. We'll come back at 1 Mountain Time and have an afternoon presentation. So, all right, and thank you to our sponsors and all of our attendees as well.
All right, thanks, guys.
Absolutely. Thank you so much.
All right. Well, welcome back, everybody, to the afternoon session of Elevation's Geospatial Summer Series. Thanks again to our platinum sponsor, Nearmap, our gold sponsors, Wolpert, the University of Wyoming Geospatial Information Science Center, and Frontier Precision, and our silver sponsor for the week, Datamar. Thank you to all our presenters and instructors as well. We're using Zoom webinar where all attendees will be on mute. These sessions are being recorded, and there is a Q&A option to ask questions of the presenters. There is also a chat feature which should be used for technical issues and will only be visible to presenters and the host. If the presenter opens up the session to attendee participation and you would like to speak, please raise your hand and you will be unmuted. So with that, I'd like to introduce Jason from ATG USA, and he will be giving a workshop today on making sense of the Esri and Autodesk connection. So with that, I'd like to pass it over to Jason and take it away.
Well, thank you, and welcome everybody. Thanks for coming to my session today. I'm happy to talk about this connection between Autodesk and Esri and everything that's been going on over the past couple of years through the Autodesk and Esri platforms and how they're starting to talk to one another. My name is Jason Artley. I am a senior technical specialist here at ATG. I'm an Autodesk certified instructor as well as a Bluebeam certified instructor. If you have any questions about any Autodesk or Esri connection things, my email address is on the screen. A little bit about ATG. We are a reseller and service provider for many different platforms of hardware and software. We're an Autodesk Platinum partner and Esri Bronze partner. More information as well as all sorts of free resources can be found on our website shown. But today we're going to be looking at the Esri and Autodesk partnership. And what I want you to take away from today is understand some of the history. And then we're going to dive into some of the data possibilities with ArcGIS Online. And then I'm going to work through how this data is starting to integrate with a software called Autodesk InfraWorks. From there, we're going to dive into Autodesk Civil 3D and Map 3D, and we're going to work with that GIS data and see how that comes through. So we'll go fairly plain Jane with the PowerPoint. I'm not a huge PowerPoint fan, and I'd much rather show you in the software, but I do have a few slides to show you. So we'll go through these topics. As mentioned before, there's plenty of time for questions. So if you have any questions at all, please use the Q&A panel on Zoom. I'd be happy to answer them for you. Let's start with history. A short history lesson. About 3 or 4 years ago, Jack Dangermond, the co-founder and president of Esri, sat down on the Autodesk University main stage with the CEO of Autodesk, Andrew Adingnost, and they publicly announced their partnership. And it's pretty rare among software giants because in a lot of ways they are competitors. But they figured by working together, they can be and bring positive change to not just the software workflows, but also the world. Jack and his team at Esri are legends in my mind for the work that they do to make this world better. Their outreach and philanthropic work is almost unheard of at companies of this caliber. And for me personally, I'm super excited that this partnership has given me more opportunities to interact with the Esri side of things. Now, I realize the audience here today, you all know so much about GIS and you're using this in so many fascinating ways. And I'm not going to go into deep on things where most of you know more about this stuff than I do, but I will cover the areas that are related to these workflows that we're going to be talking about. So GIS, obviously, started in 1965. It's been used in so many different industries and in so many different ways. And now we have this online portal where we can share our data and publish from ArcGIS Professional. And it's being used in tremendous ways. And I'll show you when I switch to my online browser, show you some of the ways that I think are pretty moving when it comes to using this ArcGIS data. So you're usually familiar with storing all of your GIS data on your local machine or your network or your personal cloud database, whatever you've got going on. But now, with it all being online, it's more accessible. And that's what's making all of this workflow between Autodesk work well. So I'm going to jump into my web browser here and just show you a generic look at Arc Online. If you haven't seen this before, this is where you can publish all of your data from Arc Pro, right? So in Arc Pro, you have an option to share. I'll show you that in a minute. And then it's going to get populated into your content for your organization or different groups that you're categorized to. And our group here at ATG is pretty loose. There's only a few of us that use this. And we've got all sorts of different things going on here. I've got the things that I've worked on under my content, but we also have our group and we have our organization. And we do all sorts of things with either sanitary sewer or survey points. We do all sorts of different demonstrations for this content. Today, we're going to be doing something a little bit different, and I'm going to be using data from the Living Atlas. If you haven't seen the Living Atlas, this is mind-blowing. There's so much data out here that can be added from all over the world, and it's free, essentially, and you can access whatever you want. There are 461 pages of potential data that we can add. And I'm going to be filtering that down to look at some of the things that are going to be pertinent to what I want to demonstrate. So once you have your data up on Arc Online, you can then do a lot of different things with it. You can create story maps or web applications or dashboards or share it in different ways. One of my favorite things is a dashboard. And I want to show you this one that's on the dashboard gallery from Esri about stormwater infrastructure. Myself being a civil person, and our demonstration today is going to cover more infrastructure-based things. I love this dashboard because it's showing me pipes and structures, it's showing me inlets and manholes, and I've got all of this data that's being extracted from that published ArcGIS online information that's hiding in that content. And with this, we can do all sorts of things with it. It allows me to zoom in. I mean, there's so many customizations that you can do with this data. The purpose of today is to talk about how can we use this data inside of Autodesk. And this is where, there's a small enough group here. We're all friends. Most of the people who use GIS regularly don't want the Autodesk people touching their stuff, right? And vice versa. So how are we going to make these friends and how are we going to make these connections meaningful without worrying about our data? Obviously, we wouldn't want this data here, or I'm assuming Buckeye, Arizona wouldn't want their data here to be manipulated in any way that wasn't in their control, right? We want them to be able to share it and use it, because if they are doing a new project, it's going to be important to know where those locations are. And it's going to be vital to realize or see some of these different data attributes that are assigned to this. If you caught Drew and John's presentation earlier this morning about the attribution that they were doing with their 911 stuff, it was super fascinating. And with that, these attributes that you're going to see inside of Arc Online are going to transfer over to Autodesk. So all this rich data, let's not mess with it too much, but let's go take a look at it inside of some Autodesk stuff. For that, I'll jump back to my PowerPoint real quick. I'm going to be demonstrating some things in ArcGIS Professional, as well as Autodesk InfoWorks and Autodesk Civil 3D. InfoWorks might be something that is a little more foreign to some of you. This is a software that's been out for about 10 years, and it's one of my absolute favorites. It allows for easy model creation. And for me, this is a welcome change to work in 3D instead of just 2D all the time. This software was intended, or is intended, for preliminary design, especially roadways. Doing different roadway widths and tapers and conditions and grading. There's so many things that we can do inside of InfoWorks. And what's really been neat about this software is it's evolved significantly since it came out. And with these evolutions came more and more opportunities to connect to different data. So you can easily connect to Revit, or you can connect to other AutoCAD or Bentley even drawings. And then you can also connect to shapefiles, something that is more in the wheelhouse of the audience here. But in the past couple versions, we've got this new Esri Autodesk connector, where Esri is actually connected to this. And you'll see inside of the software, once we get there, there's actually an Esri icon there that's going to allow us to connect to things. So I'll jump in the software in just a second and show you what that can do. But first, what it's going to be is, in preparation for today's demonstration, I created a model with what's called the model builder. And it allows you to select an area of interest, assign a coordinate system, and then the software does the rest. It even sends you an email when it's done, usually about 3 to 5 minutes later. And when it's done, it's going to ask you, where would you like to store this? Would you like to store it locally or in Autodesk Docs, which is the new, used to be called BIM 360, now it's Autodesk Docs. It's a cloud-based storage solution from Autodesk. And I wanted to mention this part because once we jump into the software, you're going to see that the model's already been done, but I haven't done anything with this. So let's open up that software now. And here we go. This is Autodesk InfoWorks. This is the 2022 version just came out. And when I was talking about the model builder, what this does is it allows you to go out and search wherever you want. For today's demonstration, I chose Bemidji, Minnesota. It's a place I go once or twice a year. You may have seen the famous sculptures of Paul Bunyan and Babe, the big blue ox. They're right around here in downtown Bemidji. But I'm using Bemidji because they have a lot of online data that's published to their ArcGIS online platform. And since I'm wanting to promote organizations and communities that are pushing ArcGIS stuff heavily, I like to support them. And Bemidji is a good option. Sorry for not choosing something closer to your neck of the woods over there west of me. But what you can do is you can grab your area of interest, you can draw a rectangle, and you have a 200 square kilometer limit of what you can grab. You give it a name, you give it a coordinate system, always important, and then you hit create model. And as I mentioned, once it's done, it's going to send you an email a couple minutes later, and then we can go check out our results. So I'll open up that file now. And this is what I got. So I have I think a 20 square kilometer area of Bemidji, Minnesota, Lake Bemidji over here. This is the first time I've been in this file. I didn't do anything to it. This is all coming over from that model builder. Why is this important? Because this is using GIS already. What this is doing is, through that model builder, it went out and found terrain, which isn't super visible in this part of Minnesota, but there is terrain there. It brought that over from USGS. It brought over roads from OpenStreetMaps. And it even brings over their attribution. So if we go to OpenStreetMap, we can see the name of it, we can see who did it, we can see all sorts of things. And all of these other tags and attributes from OpenStreetMaps appear inside of InfoWorks. I can get my aerial photo here is coming from Bing. And I can change that. So even though this quality is not bad, I can actually make it better. However, that takes a little longer, and it's not something that we can demonstrate today. But as I mentioned, this software is intended for preliminary design, meaning that if I wanted to go to a certain roadway and make it wider, I can do that. If I want to change how many lanes there is, I can do all that stuff. If I want to make turn lanes, I can do all that. I could demonstrate that for you, but that's not why we're here today. With this model, you know, as with most projects that involve GIS or even CAD, part of what we want to do is compile the data that we have. And this is where InfoWorks really shines. We have the ability to connect through different data sources. And as I mentioned, we have that 3D model, the AutoCAD drawings, the Civil 3D, the Revit, PGNs from MicroStation, LandXML. Here's the shapefile. I can bring in shapefiles all day long, and I can bring in shapefiles for, you know, whether they be structures. I can bring them in for parcels or anything else that, you know, can be geolocated. What makes InfoWorks different is that it's not just going to put a point there. It's not going to put just a placeholder. It's going to allow us to symbolize it because the software is built in, has so much built-in blocks or models. And in this software, they're called city furniture. So I can put in, you know, cars and fire trucks and post offices and light poles and traffic signals. All that stuff exists inside of this software. In addition to the data sources, where if I had a collection of shapefiles, I could bring them in. What we're here to talk about today is this Autodesk connector for ArcGIS. So there it is. Inside of the Autodesk software is an Esri logo. And if we click on this, it might prompt me to log in. No, it remembered me. All right. So not only did it remember me and my login, you see how it just adjusted right there? It automatically recognized the extents of my model. So it zoomed me into this area. And that part is important because this isn't going to happen later on in the other software that we're going to be demonstrating. But since I'm logged into my portal, and if I go here, there are opportunities to add new portals. So if you have your own group, you have your own organization, you don't want to just search the public stuff, you can add your portal and connect to that accordingly. I do work with a couple other firms, namely one in Tennessee, who does a ton of online utility work. And they've got their own organization, and they've made it so the Autodesk users can connect to that fairly seamlessly. And when we get into Civil 3D, I'll perhaps demonstrate that. But here again, as we saw earlier when we were on this Arc Online here, where we had my content, my favorites, my groups, that's also here inside of this Autodesk connector for Esri, or Autodesk connector for ArcGIS. I can search public data, I can look at my content, I can look at my groups, and I can look at everything in my organization. For this, the reason I wanted to use Bemidji is because they've got a lot of public data. So let's go look for it. Bemidji. No, I was going to misspell it one time or two. So here's everything that's tagged with Bemidji, and here we're seeing it's got too many results. But let's go ahead and take a look at what's in here. I've got aquatic invasive species, bathymetric contours, aerial photos that I could use. I've got the airport. I've got roads. Got building values, city parking, fire hydrants. That's going to be interesting. Let's go ahead and click on this. So I'm going to select fire hydrants. Now, one thing to note, if you do start playing with the software, this interface is fairly constant between InfraWorks, Civil 3D, and Map 3D. And there's two ways to select things. I can select this little box, put a check mark, and I can select the overall image. And they behave differently depending on how much data is in there. Let me click on one of these. There we go. Like this has a ton of different data on here. If I click this box, it's going to select everything. And that's going to make things tricky. I don't want to have to go and uncheck different things. So your best bet, click on the image and then select from the layers that will be available to you. And as you saw with this option, there's all sorts of different information that you can choose, depending on what's been published and made available inside of ArcGIS Online. But I want to choose the Bemidji fire hydrants. So here I can go and select a layer for water hydrants, and it's going to warn me. It's going to give me this little warning symbol, meaning that I have to select what type of feature this is. So I'll come down here, and it can be city furniture, a drainage structure, a pipeline connector, point of interest, or a tree. Well, as I mentioned, InfraWorks is loaded with a bunch of 3D models already, and those are called city furniture, and that's what we're going to classify this as. Now here on the right, I have an option for an eyeball to turn things on and off. If I select that, we can see that this area of town is well populated with fire hydrants. So I can turn that off, and we'll go ahead and add these to my design project. And I can select from multiple sources while I'm in here. Another thing to note is that we do have a layer overview where I can go see that who had put this in. So here we have an employee of Beltrami County, put a description, good use of tags, got all the information. I can select the layer data source here as well. But I can see it's fairly up to date. And I know this is a trustworthy source. I'll go back, make sure I have things selected, and go to add to my design project. It's going to take a few minutes. I'm going to open the model. It's going to have to upgrade things. And then takes us right back, adding that data to our model. And as this catches back up, we're going to see inside of our data sources an option here for those water hydrants. And it says it's been imported. But I'm going to go ahead and click on this, double click on this to configure it. Because what I want to do is give it a style. And you'll see that it saw the word hydrant, and it assumed that I wanted to make it a hydrant already. So I have built in here red fire hydrants. I've got gray ones. I've got all sorts of things, as I mentioned before. Trash cans, street lights, coffee shops, bus stands, bike racks, street grates, all that stuff. I'll leave it on red fire hydrant, and I'll hit close and refresh. It's going to go on through, and now we can go look around, and what we're going to see is those hydrants. So right here, that's not just a 3D model that I placed in here. That is an actual geolocated GIS data asset that's been placed in here, and this model is set to the same coordinate system, and that is accurate. And this model isn't perfect. Obviously, it needs to be cleaned up with some of these roadway intersections, but that can easily be done. But with this data, I can now do all sorts of things. If I were to use this for a preliminary design, now I know where my fire hydrants are. So now I know that maybe when I'm working on adjusting this sidewalk, I need to move it out of the way so it's not encroaching upon that fire hydrant. Or if it's a manhole or any other utility or whatever GIS data that we're bringing into InfoWorks, since that's geolocated and it's connected through Arc Online, that means we have a real-time connection. Should that GIS data ever change, this is going to update as well. So instead of just a 2D drawing in ArcGIS or a Pro or Civil 3D or AutoCAD, whatever we're bringing in, we have it here in InfoWorks in a nice three-dimensional interface that can allow us to do all sorts of things. Let me find a nicer intersection. Here we go. Now, why is this important? Well, for one, InfoWorks is a really easy program to learn, and it's fun to use. Frankly, that's one of my favorite things. But what's interesting about this is it's a whole new way to interact with this. And when you've probably heard it. If you haven't heard it, you will hear it. There's a new buzzword getting thrown around all the time called digital twin. And for those of you on the GIS side of things, you've been doing that for years, right? You've been working with GIS, and the digital twin aspect is not entirely foreign, but it might be in the 3D sense, right? So in the 3D sense of things, this is all new, and this is super exciting because we can make all sorts of changes to our roads, to our plannings, to our buildings. We can see all these things and connect to our data in meaningful ways. Now, there's a question about this. What kind of account do you need to access this? On the Autodesk side of things. So with that, it is now essentially subscription-based, where you have a named user account. And you can buy Simple 3D, and you can buy AutoCAD, and you can buy Revit separately. However, they are, let's see, the best way to get them is in what's called the AEC collection. So if your firm has the AEC collection, they already have access to InfoWorks. And most firms buy the AEC collection instead of just getting Civil 3D separately, because there's more value there. So you get Revit, and you get Navisworks, and you get InfoWorks, and you get Formit. You get some of these other pieces of software all bundled up together in that collection. So if your firm is a Civil 3D firm, talk to your IT, see if you do have the AEC collection. If so, you can install InfoWorks. Now, this connector function is going to come in natively. And even if you don't have an Esri account, you can still connect to that public data that I showed you. So I'm not using any of my ATG data, nor am I using any portal data. I'm using strictly the free public data to bring in these fire hydrants. Now, if I wanted these fire hydrants to be turned into trees or sunflowers, I've got all of that capability here in InfoWorks, but that's besides the point. Now, I could bring in my property lines, my actual building footprints. I can stylize them in different ways. I mean, this is just a high-level overview of what InfoWorks can do with that Esri online data. Now, what's even more interesting, and one thing I really want to highlight today, this is not a one-way connection, meaning that I can go through and actually draw in and make changes to things and write that back to GIS. So we need to be very careful with the permissions of things that we publish. But let's see if I can make that happen. So, and part of my preparation today, I was like, let's just do everything live, because that's more fun anyway. And I'm just going to drop in a simple storm network. So again, me being a civil guy, I'm going to think of infrastructure and roads and utilities. So I'm going to drop in a storm network, and we're going to see what we can do with that as far as GIS. Now, these fire hydrants are part of Beltrami County. I don't want to mess with them, but I can. See this? I'm moving that fire hydrant. Now, I could go back, change its feature class, but since it's protected from Beltrami County, I don't have an option to write it back to GIS. Some assets that I bring in from my organization are able to be republished back to where it came from. Right. So even though I can move this graphically, and should that data refresh, it should move it back to where it came from, because again, it's a live link. Now, while I have this selected, I do want to show you that we have the properties of our object, right? I have my fire hydrant symbol, I've got the ID, but if I come down, all of those ArcGIS attributes are visible. City ID, northern easting, elevation, was it flagged, etc. Really important stuff there. I can still customize those attributes. I can create new things inside of here as well. So while we're are trying to focus on Esri-based things, this software alone, even though it's not intended purely as a GIS tool, could certainly be utilized in that manner, right? I can draw in utilities, I can draw in parcels, I can draw in those things and publish them directly to my Arc Online from here. I'm going to come over here, as mentioned, I'm going to draw in a simple drainage network just for something in here. And you'll notice all I got was these inlets, which are improperly placed in the middle of the road. I can make them into manholes, that's besides the point. But if we go underground, there's my utility. Now think about this for other firms and agencies that have a ton of elevation correct GIS assets in their Arc Online portal. So now when I'm designing roads and NFORCs, I can go below the roads and see all of that utility information. Let's go back to the ArcGIS connector and see what Bemidji has. I don't know if they had anything in here or not. Let's see. We found the fire hydrants, fire stations, parcels. That'd be a good one to bring into. Park features, refuse route, sanitary sewer. Oh, we're getting closer. Storm drain. Areas. What's this? Sewer main. Perfect. Look at this. I'm going to be able to bring in the storm sewer for this entire city as pipelines into my NFORCs model. Go take a look at them. They do exist. Now it's just going to give me the pipeline. It's not going to give me the structure. Those might be located. There's catch basins. There's ditches, storm manholes. Let's bring those in too. We'll call those pipeline connectors. And let's add this to our design project. Now it's only going to grab what's inside of my area of interest, right? So it's not grabbing everything for the entire community. It's only grabbing what's in that particular area that I selected. So I could essentially just grab a couple blocks at a time. If I was really working on something small, it would work pretty well in that manner. So we'll let this catch up. It's adding a ton of data. It's connecting, to that Arc Online from what was published by the city of Bemidji. And here we're seeing those pipelines, and they're appearing above ground. That's okay. That's easily fixed. Because what we're seeing here is that this data doesn't have elevations assigned to it. If I close my data sources, come down here, I have a diameter, I have a calculated length. I don't have elevation information for this particular set of data. Now, if it did have proper inverts, NFORCs is smart enough to calculate it that way. But instead, we're going to go to our data sources. I'm going to take my storm sewer pipes here, and I'm just going to kind of fake it. So up here in Minnesota, it gets pretty cold. So we want things a little deeper. I'm going to go ahead and offset things on a Z value, and I'm going to kick them down 3 meters. And we'll let this refresh. Hopefully that's going to hide our pipes under the ground. There we go. Some of these facades aren't perfect, but those are easy to change. It's a whole other story. But now if I go look underground, oops, I went too far. See him hiding over here? I offset in the wrong way, wrong direction. But if I were to be a little bit more careful with my information, I can have all of my data that I bring over and have that come in, where it's closer to realistic, just below the ground, and be able to see how everything interacts. So if I was doing water and storm, sanitary, not only could I see them, I could stylize them in different colors to make them be more meaningful. Now, once upon a time, I don't know exactly when they stopped using this feature, but there was a function of InfoWorks that was supposed to be more tied with field workflows. And they had it geolocated so you could use an iPad and walk out in the field and view your InfoWorks model on your iPad. And then when you looked down through, the iPod or iPad location and the accelerometers in it to know the angles it's going, you'd be able to sit there and point your iPad at the ground and visually see the InfoWorks model, see the pipes underground with it at the same time. Now, there's new technology that can replace this, but this is what InfoWorks was thinking 10 years ago, 8 years ago. And it's really exciting because this function, I would imagine, will come back, and it's going to mean a lot more for us that are integrating these field workflows as well. One thing I want to mention about these assets, if your firm is doing things with the ArcGIS field collector, where you actually have somebody out there with a device collecting data in real time, if you're connected to it, they will pop up in real time in InfoWorks as well. So if they're collecting streetlights, the streetlight will pop up. And by the time they get to the next one, the other streetlight will pop up. You might need to rotate them a little bit, but it's XY location, it's northing and easting, will be just as accurate in this software as it is being collected in the field. So some fascinating aspects to the software. So InfoWorks, of course, I could play in here all day and I could start doing some roadway design and redevelop houses and buildings and lay out a parking lot and things, but that's not what we're here for today. But let's just say quickly, I suppose I should jump over to this other model. So real quick, I'll jump to an old model I used for some training a few months ago. And the purpose of this one is to show you real quick another trick that InfoWorks can do. While that's loading up, there we go. So here's a cheesy site plan that we did in InfoWorks where I had laid out some storm drains and a bus stop and a gas station and a building and a little office complex. I put some cars in the parking lot. And there's people and a motorcycle, and that's besides the point. But with all this data, right? Let's say these were GIS assets where I had, parcels and lot lines and utilities and whatever. I'm visualizing these in a different way. I'm visualizing them in 3D. And while this software is intended to bring in all that data to help you make design decisions, this can also be used for visualization. So there's a function here inside of InfoWorks that allows you to create flyover videos. So super quick, super cheesy. I mean, this whole thing, if I go to somewhere to the beginning, will allow you to, go down the road, see different things. You can create different annotations if you wanted to. If you wanted to show different captions on certain assets, you'd be able to do that. And you're presenting this in a manner that's not unlike what we saw on the dashboard, right? I can use all my rich GIS data and visualize it in a dashboard, which is fantastic. And of course, there's ArcScene, and there's a bunch of other Esri-based products that can do visualization in 3D. But here in Autodesk, it has that connection to Esri built right in. Right? That button is right there. So it's a lot easier to deal with. And it allows me to make these changes and things accordingly. Now it's all great because I've simulated the time of day. So I can actually set my model for today, June 9th at, Minnesota time, 2:39 p.m. And I can simulate the sky. So I can do shadow analysis. I can do all sorts of things. I'm getting off track here with my love of InfoWorks and how powerful it is. But the fact that we can take this and bring in our GIS data is absolutely fascinating to me. All right, for that, I'm going to jump out of InfoWorks. I'm just going to close that guy down, save a little bit of bandwidth. That software is kind of unique. There is no save button. So after everything that you do, it is saving automatically. So today we're going to jump over. We're going to stay in the Autodesk realm, but we're going to look at Civil 3D and Map 3D. Just like what we saw in InfoWorks, there is that new button that gives us an option to look at different things. Now, if you're not super familiar with the Autodesk side of things, let me give you a little bit of background. Autodesk makes AutoCAD. AutoCAD has been out for many years. CAD and GIS working together isn't unusual. Autodesk has their own GIS platform, which they call Map 3D. It can do a lot of what Esri products can do. Not perfect, but no software is. But they have their own Map 3D, and then Map 3D is built upon AutoCAD. Civil 3D is built upon Map 3D. So if you have Civil 3D, you automatically have Map 3D. The opposite is not true. If you have Map 3D, it's not guaranteed that you have access to Civil 3D. And it's important to know which one you're in. And I'm going to show you how to get from one version to the other. The reason being is that you're going to see the same button in both platforms, right? It's the same button that we just saw in InfoWorks. But here in Civil 3D and Map 3D, while the button looks the same, they do different things. So let's dive into those software. We'll dive into that software and we'll take a look at it. For today's demonstration, I'm going to be using Civil 3D 2022. This is the brand new version that came out. And there is a key part of why I'm using 2022 versus an earlier version. So this ArcGIS connector found on the Insert tab of the ribbon. This appeared a couple years ago in version 2020.1. So when I launched Arc Pro this morning, I got another update notification. And part of that whole subscription model or maintenance model is that you get updates more frequently. And with Autodesk, that same thing applies, where there are frequent updates to the software. And with Autodesk, how they do it is I call them .1, .2 updates. So 2021 comes out, and then a couple months later, they'll release .1, which will add new features and bug fixes. And then a couple months later, there'll be .2, more features and bug fixes, so on and so forth. When they released 2020.1, that's when we first saw this Arc connector for GIS. And it worked fine. It can do just about everything that it can do now. And it works the same way. Here in 2022, we're gaining the option of bringing in aerial photos now, which is pretty exciting. If you work in a house where, and by house, a company, where you're trying to get GIS aerials into Civil 3D, I'm sure your IT people are probably freaking out because it's not usually an easy process. Through this connector, you can push up all the aerials that you want to see, and they can go grab the piece that they want. So you don't have to clip stuff for them anymore. You don't have to geolocate them for them anymore. They can use the connector. Now, again, and I'm not trying to highlight the rivalry between CAD and GIS groups. Hopefully there's some folks on the call today that speak both of those languages and they know where I'm coming from. But we're going to be going through the Civil 3D workflow to add data. And then we're going to go through the Map 3D version of adding data. And this, what I want to highlight through this portion when we're talking about Civil 3D is giving folks access to what they need, right? Through all of your geo databases and all of the amazing things that you've created inside of your Esri platform. Again, Esri and Autodesk does, with your certain permissions, it will allow you to write back and forth, right? If I go over here and select this pipe that I drew in, I can move it to an ArcGIS layer, right? If I bring in certain things, I can write them back to GIS. Now, this that we see in here, these are all alignments. So alignments in Civil 3D are typically used for roadway center lines. And these right here are points. So if you've ever seen a survey drawing, you've seen 1,000 of these. But what these are inside of this file, again, is all pieces of data that were brought over from the ArcGIS connector. So I just selected that button on the Insert tab of the ribbon. I'll do it again. Insert tab, come over here to ArcGIS collector or connector. It's pulling this up. Now, it's not taking me to Bemidji. It's not taking me to the extent of my model. It's taking me to my neck of the woods. I have to go physically find the location of my model. This is something that's different in Civil 3D that doesn't happen in InfraWorks. Right? So same thing, grab my area of interest, grab the stuff, go search public, Bemidji. Can I grab fire hydrants? I think I did grab fire hydrants already in this model. But let's go find sanitary sewer manholes. There's a line, there's a manhole. Perfect. I'm going to tell these to be structures. And I'll tell these to be gravity pipes. So in here, if it's a line, I have alignments, focal points, feature lines, and gravity pipes. If you're not familiar with Civil 3D, it's meant for obviously civil things. So pipe networks are a big part of Civil 3D, creating those gravity and pressure-based networks for storm and sewer and water, etc. Feature lines are typically used for grading. If I need to do some site grading or use them for anything else, they have horizontal and vertical control. And with this, I can choose feature lines or gravity pipes for that line. I could use alignments or focal points. This is a weird choice for a line. I wouldn't choose that. Most people are going to choose gravity pipes or feature lines. Now, gravity pipes, it's going to be looking for an invert, right? It needs to know where it's placing these things. And as we saw earlier, that gravity pipes inside of, or the gravity storm drain didn't have that invert information. So in the true beauty of a live demo, let's see what we can find for public data. I'm going to go ahead and add gravity pipes and gravity manhole structures, all from this free data. Let's see what comes in. So I'll hit add, and it's going to connect. So the points that we see here, I'll pull that back here in a second. The points we see here already are the fire hydrants. And here we have the roadway center lines. What I selected was my gravity pipes. And here we see a familiar term, schema mapping. I can go find different information and map it So how I want this to come in. We'll start with the sewer pipes. Since I chose gravity pipes and not feature lines, it's going to prompt me for this information. And what you'll see here is an ability to save, an ability to import. So again, you can configure things for your organization so they come in consistently every time that you use that connector. So for firms really looking at, making both sides of the firm work more efficiently together, you can create these mapping files that they can refer to. I have default values. So here's my inner pipe diameter. It's going to default to 12 inches unless I tell it a certain information. And I can tell it what's going on here. And you'll see in that property, I have a diameter. So it's going to pull in that data because these are all the attributes that are assigned to that storm or that sewer pipe inside of ArcGIS Online. I'll go diameter for this one. Let's see, invert. I don't think I have invert in and invert out. I do not. That's okay. I'll leave that as is, and I'll jump over to my structures. Same thing. I've got easting elevation. I do have an elevation for a rim. Structure depth, structure height. No, it's not telling me rim, but sump depth. This one. Benching method. Part size ID. Again, we can use all sorts of things. Maybe I'll choose this object ID. Let's see how this pops in. Go ahead and hit OK. And it's going to start importing this data. So it's querying ArcGIS. It's importing this information. It's telling me, it's giving me errors. Find the default value because the source property name couldn't be found. Of all of those little pieces of sewer pipe that are in there, it happens. We've all seen GIS data like that may not be fully populated with the proper attribution. But now it's creating all these structures. And it's doing all this stuff for us. Once this is brought in, had it been at the right invert, had it had the right slope, it's going to allow us to do analysis. It's going to allow us to do all sorts of things without having to draw it in manually. And that's always been the hard part. As easy as it is to bring in shapefile information into Autodesk or AutoCAD or Civil 3D already, it's been impossible to do storm or utility work with it because there wasn't a way to make those pipe networks out there. You had to go recreate them or trace on top of them. Now I'm able to bring those right in and do stuff with them. We go take a look here. I have all these pipes now. Look at that. It's kind of crashing a little bit. It's not super happy about how much data I brought in there, but that's okay. We can see on the screen, although we can't really see my cursor for some reason, I have pipes and I have structures. Really cool stuff. And if I go over to the prospector, so for the tool space, so Civil 3D operates in a tool space. If you haven't seen this before, this is the same thing as our catalog essentially, and on the ArcGIS side, where we can go through our different information. We can see what's in here. I have a ton of alignments here that are based on those roads, and those weren't drawn in perfectly. They have just master GIS. They don't have actual meaningful names on them, like Main Street, Elm Street, and all that other stuff. If they did, they would have appeared here. We can go take a look at our pipe networks. Here we see our ArcGIS network. And if I open that up, I can see all of those pipes. Here's all that data that's living down here. I can see the information, some of the styles that were set. And I have all my structures and all of that information. I can go select one of these, go to the structure properties. I can see, northing and easting, whatever information. I can see what pipes it's connected to. So now I can start to do my design off of that. There's so many things I can do. Really, really cool stuff. Now, ignoring those pipe networks because it's not super happy with me, we can go look at the other data that I had brought in. So since my cursor isn't working perfectly, this is the point that I'm after right here. Oh, come back. There we go. Clear. All right. So that's the point that I'm after. Now with Civil 3D, all points, or let me just back up. In Civil 3D, everything shown, you know, the symbology of it needs to be created as what's called a Civil 3D style. So if I wanted a symbol for that point 246 that was a fire hydrant, I need to create a style for that that is a fire hydrant. So if I come over to my settings tab of the tool space, this is where you can see all of the styles that are pre-populated with Civil 3D. Now, getting further into the weeds about Civil 3D, most firms that use Civil 3D should be using a template. Template is going to have all your styles, all your layers, all your stuff in it already. For this instance, I used the Civil 3D default template, which does contain a point style for an existing hydrant. And if I look at my label styles, I have description. I have some information in here. We're going to go configure some of those things here in a second. If I jump back to the prospector, this is where I can see what's inside of my drawing. And if I look at my point groups, I can see all of my wider hydrants, right? These right here. And if I hover over there, it tells you ArcGIS, Bemidji fire hydrants, water hydrants, dash Cobra points. It knows where it came from. If I right click on this and go to properties, I can tell it, hey, take everything in this point group. This point group came in automatically. I didn't have to create it. This appeared when I connected to that data from Arc Online. So another key piece of that functionality is that you've got folks on Esri working with folks on Autodesk saying, well, what do I do with this data once it comes in? And Civil 3D is going to say, well, we're going to put it all in a point group for you because that's going to make it easier to manage. And with this, I can grab all of those water hydrants. I scroll down, I probably have 100 in here. Now I can tell them my point style is an existing hydrant. And my label style, let's give it description only. And I'll hit OK. And now my cursor is not working, but you can see that that point changed. So with this, I can now add different labels too. So I'll jump over to my settings tab again and look at my label styles. And I know this is getting deep into the weeds, but there's one of the reasons I opened up Civil 3D 2022 instead of an older version was because now finally inside of Civil 3D, I have the ability to use my properties in here accordingly. So I'm going to create one for flagged. That was an attribute that I saw on these files. I want to toggle on a label that's going to make a yes or no or a flagged status appear next to my point. So I'll come over here to layout and my description. I'm going to go over here. And it's hard to see because of my Windows settings, but there's a piece of text in here that's looking for the description of that point. But now here in 2022, I have property sets. And if I click on this tab, look at this, ArcGIS. Here are all of the attributes that appear that came over from Esri. So I can go over here and go to flagged, and I'm going to push this data here. This little arrow has been a bane of my existence. Push this data over here. Now you see that coding appears. And I'll hit OK. And I'll hit OK. If I go back to my prospector and go to the properties of this point group, I can tell it to go to my flagged style. Oh, look at that. That fire hydrant is flagged. The other ones would say no. And I can filter it. I can do all sorts of things. I'm using generic data, or I shouldn't say generic. It's well curated data from Bemidji, but I'm using the default Civil 3D styles to visualize this. And wondering why my cursor is freaking out though. But there we go. There's a hydrant. Now it says yes, because that's flagged. This is just one way to use this data. So if you are working on getting things over to the Civil 3D side of things, if you start in 2022, your life will be better for it because you'll have that property set capability. If you're using an older version, you can make that property set data. Let me show you what I mean. I'll go to that flagged, pop over here. See this over here? This ArcGIS code. You can put all that in manually and it will work in older versions, but you just have to type all of that out. So it's much harder. You could go create it in 2022, copy paste the code into an older version, but that's really not worth the hassle. Anyway, the moral of the story is create meaningful labels inside of Civil 3D that are looking at only the attributes of that GIS data. It's not fake. It's not whatever. As long as the name of that file that we connected to and the name of that attribute doesn't change, the labels will continue to work. With that, I'm going to pause and answer a question from Steve here. What is the best way for GIS data to be made available for use in Civil 3D? You used connector for public data, but what if the data is in-house or most CAD folk do not have an Esri account? How do you share data? Excellent question, Steve. So let me show you if I can get this to work. I don't know if I can. What I recommend in that case is to have your GIS admins, or the ones who are publishing data in Pro, publish certain sets of data that you want CAD folks to see. Don't give them the world. Again, there is, through certain connections, the ability to write back data to Esri, right? We don't want to do that. We don't want to, there we go. We don't want to publish that stuff to ArcGIS directly. Okay, we do have that capability. So through different permissions, we can publish things up or create feature services for the CAD users specifically for their consumption. As I mentioned, I do work for a firm in Tennessee, and they've created their own group. So if I jump back to insert and I go to the Arc connector, we saw my groups right here. If you create a group for CAD users, so call this CAD access or for Civil 3D users or for whatever department, then you can take all of your amazing data and just give them the piece that they need, right? Whether they be aerial photos or pipelines or parcels. Give them the piece that they need. It's less for them to filter through. And then you know it's exactly what they're intended to see, right? To do that, they have to connect through the portal. So like I said, I'm using public data and I'm logged into arcgis.com. If I go to a different portal, like my company portal, they're going to need to create that account. I've got ones for different firms that I work with. If the CAD folks don't have that Esri account, that's where things get a little weird. Because you can have, I'm pretty sure you can have them create the account and access it without having them have a full-blown, seat to the software. Check with your particular company, because that will be different for everybody. I mean, if you want that stuff publicly, as I'm connecting to that data, that's the easy way. But for this, I mean, you can create a guest account and have access to it. I'll see if I can get this to work, if it remembers my password, because I don't know if I do. Oh, it does. All right. So as I mentioned, I work with a firm in Tennessee, and let's go look at their data to show you how they've got this configured. So notice in Civil 3D, I can't, it's not taking me to my model. So I have to actually go to where that data is, which is unfortunate. In InfoWorks, it takes me right there. But if I go over here, so Knoxville, and I select an area of town, they've created a group for AutoCAD access. And with this, this is only the data they have available that they want their people to see, right? They've got tons of stuff, but we don't need to see all of it because we don't know what all of that stuff means, right? So let's just filter it down and get this set up. So in here, we've got images and we've got different things. For this particular organization, they told the CAD users that anything you need is going to have FS for feature service, right? So select it, and we can see all of the data they have in here. So I'm glad this worked so I could show you. Look at all the stuff that they've got filtered in here. Oh, you need to see transformers? Great. Let's make them Koga points. Click them on. Use our eyeball thing to see that they exist. Voltage regulators, breakers, you know, whatever. Whether this be water, electric, whatever utility, property lines, easements. You all know the vast world of GIS and the different things that you can use it for. But we can go through and curate what we want to share, and whether you make that public or you know, accessible to certain folks, you have to handle it that way. But public, there's, you know, with the, if you make it public and are careful with your tags, it can be somewhat hidden. But good question, Steve. I'm going to come back to this data because we'll actually bring some of this in now that I've logged into it. And I'll hop out of this particular file. So in that one, I connected to the data. I brought in the manholes. They came in as Civil 3D information that I could now go in and assign invert information to. I can connect to it. I can do all sorts of things. I'm going to go ahead and save this file and close it. And I'm going to create a brand new file. This time I'm going to go from a template. This template has been pre-populated with information. So if we go look, so as I mentioned before, inside of the tool space in Civil 3D, we have a settings tab which contains all of the different styles that have been pre-configured for us. And in here, I have points for all of the assets that are on Civil, that are on the ArcGIS feature services. Right? So these are all of the things that could possibly come in from ArcGIS connector. So this was a lot of work to get configured, but there's all of that symbology is already in here, which means that when I go bring in transformers, as I just showed, I bring them in, it's going to bring in the proper symbology that matches the GIS symbology. Right? That's the same symbol that they use in GIS. And not only will the symbol show up, the labels have also been created for that. And each one contains certain information, which follows that property set coding that I showed before, where we have the different attributes that can be read from. So in this case, I have structure number, KVA, and phase. And those labels will appear once those points are in here. see if I can get this to work. So again, we'll pop over here. I have no idea what it's taking. Oh, it took me to Bemidji for some reason. That's not right. Pop back down to Knoxville. I'll pop over here. See if we can find some of these. I'm going to make a small area using a smaller net, but I'm hoping I can capture meaningful data. I'll go to My Groups. I'll go over to Add AutoCAD Access. Let's say we did storm and sanitary before. Let's do that electric system, and we'll stay in here. So I said transformers. Let's bring those in as Kogo points, and let's even give underground utilities. So let's grab these, and these are going to be feature lines. So I'll show you a trick of feature lines in a second. So I'm just going to grab these two pieces of the data. We'll see if this is enough to cover what we want to cover. I'm going to add this to my design project. It's going to connect. It's going to think about it. It's going to pause here for a second. There it goes. As we saw before, it's going to import this information. And when this happens, when it's done, we've got some feature lines. So we've got some underground stuff here, and we have those points. And again, my cursor is freaking out. We'll jump over to Prospector, and here's a point group, right? Automatically came in, already configured. All I got to do is tell it what I want it to look like. Well, let's make you an electric transformer because that's what you are. Let's label you an electric transformer because that's what you are. All right, so through that configuration, it has all this pre-configured or already set up. Now when I zoom in, it should give me that information. This is a bug that I actually emailed Autodesk about today. If I go in here, mess with this label style real quick. There's my property set as we saw before. I should hopefully fix that issue. Interesting. Oh, the beauty of live demos. There we go. So yeah, I've got my structure number, my KBA, and my phase designation. All in there from, oops, back. Those are from that property set, right? So here are all of the attributes that exist for that particular transformer. I could choose which ones I want and then add it accordingly. There we go. Now it fixed it. See? So if I zoom in, got the structure number, KVA, phase designation. So all that information is in there. It's much more meaningful now. My feature lines that were brought over, I can do similar things with them. I can go look at my feature lines in my prospector. If I bring this out, you can see all of them in here. Those are all what they're named. There's not a whole lot in here, but I can grab all of these, give them a style. Those are primary conductor underground. That's already been set up. So now they have a certain color and appearance that they're going to show up. I didn't grab all of them. And then I can grab this and there it is. So now it has a specific style for line type and everything. So it appears with a proper stylization. This has always been one of the problems with bringing in GIS data from AutoCAD, or let me take that back. Bringing in GIS data into AutoCAD is we lose that symbology, the stuff that we worked so hard to have in GIS Pro, where it's all set up. You know, I've got, if I pop over here to Pro, where I have all of my different line types and my stylization, we lose all that. But since we've configured Civil 3D to have all that information, you know, that's a whole other side of CAD management stuff that we're getting into the weeds with. But we can make them match so that the results you get between Esri and AutoCAD aren't that different anymore. So that's a big part of this workflow. But you can see what we've got going on. And same thing, I can go in and if my cursor was working right, select, right click. Let's put a label on this thing. Oh, add label, single segment. Without a functional cursor, it's not going to work. But typically you'd be able to add a label, and there's also a label style for that, which would show primary conductor, or I forget which one we had for this one. Feature line styles. Underground. This one is looking at the property set that tells us looks like operating voltage. That's meaningful data that I already have populated in here. So what I'm doing is I'm standardizing the information that's coming over from ArcGIS. Not only can I bring in the line work, or can I bring in the symbol, now I have it configured in a way that labels it the way that my organization wants it to be labeled, right? If I needed to go in and tweak something and add a different attribute, that's fine. But this makes it easier for people on the Civil 3D side to interact with that GIS data and just get the information that they are intended to see. So as we saw before, through that portal, you can create a group, publish the data, let them see what they can have, and go from there. Now, I'm going to take all of that stuff that I just talked about and throw it out the window. What do I mean by this? I have connected to that data here in Simple 3D, but part of what I wanted to talk about today was what happens in Map 3D. So how do we take our Esri ArcGIS Pro online stuff and bring it into Map 3D? What's going to be different? Let's find out. Now, as I mentioned, Civil 3D is built on top of Map 3D. So I'm not going to close the software and open up Map 3D. I'm going to change my workspace. So Civil 3D by default comes with 4 workspaces. There's Civil 3D, which contains all of the civil assets like roadway and railway and utility stuff. Or I have drafting and annotation, which is going to strip out all that stuff and turn it right back into plain vanilla AutoCAD. I also have AutoCAD 3D. So if I wanted to model in AutoCAD 3D for some strange reason, I could do so. But planning and analysis is actually Map 3D. So if I click this button here, I'm going to redo my workspace. And here we go. Now we are in Map 3D. Same thing with my cursor being missing. This is wild. All right, I'll work through it. So if you haven't seen Map 3D before, I do have all sorts of connections where I can connect to ArcGIS and ArcGIS Online. Those are newer. I've got my SQL and my Oracle and my shapefile and my SDF and all sorts of things that I can connect to. And this is traditionally what would be used to connect to your organizational GIS data. They don't have to be on Arc Online for this. But for the newer versions, you're going to see this ArcGIS Online connection and the ArcGIS connection. Before, it wouldn't say that, because why would Autodesk want to mention the competitor software, right? Shapefile is good enough because that doesn't have to be Esri, right? Whereas SDF is Autodesk only, as far as I know. Anyway, instead of connecting through that way, we have that same connector that we saw before. And this time, right next to it, we see our publish to. So I can create assets here. If I had a functional cursor, I could create assets, create my points, create my polygons, and publish them directly to ArcGIS. Instead, I'm going to use that connector again. And we're going to load up. Again, it didn't take me to the right area. This is in Knoxville still. Oops. Go down here. Somewhere in here is where I selected, I hoped or believed. I'll grab that same area. Make sure I'm in the proper portal. Yep. Go to my groups. There's my AutoCAD access. Again, I can see what that organization wants me to see. So it's a little tip for those of you that are publishing this data. I'll stick with the electrical theme. And this time I'll choose go overhead conductors and poles. Those should appear. Now here, when I add them to my design project, you'll notice it's not asking me for a type. When we were bringing in data in Civil 3D, it was asking us, well, is this a COGO point? Is it a structure? Is it, this? Is it a feature line? Is it a gravity pipe? And same thing when we're in InfoWorks. It wanted to know, is this city furniture? Is this a point of interest? What data type is it? Here in Map 3D, it's not giving us that option. These are just going to come in as layers within Map 3D. So I'll go ahead and add those to my design project. Windows are a little different. Reading that feature class metadata. Thankfully, it's taking long enough for me to take a drink, but it's not going fast enough. So we'll give this a couple seconds to churn through. Poles has the electrical poles for this area has a lot of data, as we're seeing this pop up. There we go. And there we go. So here's all of that information. Now I have this mix between the Civil 3D assets being COGO points and feature lines. And on top of that, I have my map layers. And inside of Map 3D, they don't have a tool space. They have what's called a map task pane. We'll toggle that on. And here we go. Inside of that electric system feature service, I have my primary conductor, which I can stylize. Now, you'll notice I have to do this manually, right? I can't, let's make it yellow instead. I don't have things automatically set up. There's no seed file to get this to work right, which is not my favorite part of this. But we'll go ahead and do that. Close this, and then let's make our poles look different. Same thing. I have style. I can go through, choose different symbols, make those circles with 6. You're familiar with this type of thing. I'll now close that, and we'll go from there. So I'm still bringing that in. It's looking very similar to it would if it were in my Arc Pro, right? If I had different symbols in here, we're used to working with them in our content. But here in Map 3D, we're using the map task pane, where then we can go in and create labels for these things manually. We have access to all of the attributes that are here. What would I want to see for a pole? Place by, pole use, stamp, structure number, street light. Let's do structure number. So again, it's reading all of that attribution. Again, it's connected through Arc Online, meaning that it is text. That's all you got. That's not a very good attribute to choose. But with that data, should these poles move, should those conductors move, or be added or changed in any way, it's going to update in real time here on the Autodesk side of things. With that, we've got a few minutes left. If you have any more questions, please type them into the Q&A box. Otherwise, I'm going to keep rolling here. So what I wanted to work, and for some reason my 2022 isn't super happy. I'm going to go ahead and close this. I'm not going to save it. I'm going to jump over to not PowerPoint. We're actually done with that. Lucky you. I'm going to go to 2021. So I'm going to go to an older version of Civil 3D just to see if this is going to be any more stable. Now, as I mentioned, or I didn't mention, but with Autodesk stuff, anything 2018 to 2022 is fully backwards and forwards compatible. So there's no issues there. Let's see if my cursor will appear in this file. There we go. So far, so good. So now we're back to this data that I've already connected to, right? So I've got my poles, I've got my manholes that all came over. Now, what I wanted to show here, I think I already did it in this file, but of course I made it a color that it doesn't stand out. So let's see if I can find it. There. No. Let's go ahead and add something. So what I can do is I can go in and let's say this is a parcel or a building footprint or whatever. I have the ability to go in and go to my output tab and publish that to my ArcGIS. Now, this is where I want to be super careful and not write to my client stuff, and I'm not logged into my ATG portal currently. So let's see if I go back to me. Okay, there we go. So since I've already connected to a bunch of things inside of this drawing, it was kind of freaking out. It had to go read all of the alignments that are in here. It wants to know what have I done to the data that I've already brought it in. And these are the things that I can publish. So I have point groups. So if I would have moved or added anything to those fire hydrants, it would republish those. If I had moved, changed things to my alignments or given them profiles, it could publish those to add elevation data to this. Now, if we come down to the bottom here, other Civil 3D objects such as offset alignments, rail alignments, feature lines, as we saw before, sites, and pipes. If I try to pick this polygon that I have selected, nothing is going to be found. For that, we would use the map export command and just make a shape file out of it. I would need to make this into one of these attributes for that to be a publishable, if that's a word, a publishable asset. So a feature line, that could certainly work, but that is not a feature line. A feature line inside of Civil 3D has both horizontal and vertical information. And I believe those Z values would be accessible through an attribute when it gets over to the Esri side. All right. So they can talk back and forth. You want to be careful with your permissions to make sure that your users have or don't have the right permissions. As I mentioned, I worked with a farm in Tennessee that has that certain set of data, and the best practice that we've assigned for them is that on the Civil 3D side, right? If they're just looking at the data because they need to use it for design decisions, they're going to use Civil 3D, that Civil 3D workspace. If they're going to be manipulating the data, adding new attributes or adding anything else, they're going to use Map 3D. So the different users have been separated that way accordingly, saying, okay, well, these users have that permission, they can write it back and they can publish to ArcGIS. The Civil 3D users cannot, and they've been restricted on that side. So it's a little bit more work to manage, but hopefully what you've seen through this demonstration this afternoon is that there's just so much that we can do, right? And that data that we're bringing over from ArcGIS is no longer just a simple point or a simple line or a simple polygon as it has been before through just shape files. Now that we have these buttons available to us inside of Autodesk products like Civil 3D and Map 3D, we can bring in that data from Esri in a much more meaningful manner And if we have our Autodesk platforms stylized accordingly, we're getting more consistency between those two software, because I have, my pole looks like a pole, my lines look like a line. You can have that configured where it mimics the Esri side quite well to make the drawings that are usually done in Civil 3D much better. So with that, we got about 1 minute left, and there's no questions in the Q&A. I will go ahead and pass it back on over. Thank you for your time today.
Yeah. So I have a question, and well, I guess I'll just ask it here instead of trying to type it out or anything. So we've used it a little bit, but so what we were looking at there with setting up your organization templates and stuff, is that kind of like, because we were thinking like, okay, can we bring this GIS data and have it imported into blocks? Does setting up that template, is that kind of the same deal?
Yes. All of the blocks that were created were inside of or the blocks that were created to mimic the Civil 3D or the GIS look of those symbols. And then from there, each one of those blocks was created into a style. So on the settings tab, if I go to point, there's a style created for each one of my things. I'm not in that particular template right now, but with these styles, you can tell it what block to use. So in this case, this style says go find, the guide pole block. So you would create a block or a style for each of your assets that would be coming over from the connector. Again, this is making it simple for we'll say the simple folks that are going to be interacting with your rich GIS data. If it's a sanitary manhole, make it called sanitary manhole. They don't have to think about which one's correct. So you'll want to create styles on all that.
Right. So is that something that's available on just the 2022, or is it available on the 2021, or?
The ability to create styles?
Right.
That goes all the way back to the beginning of Civil 3D. This using styles is how most Civil 3D work is done, but you need to manually create them because they won't exist. I mean, this is what comes in the out of the box template, which isn't very good. So your company template likely has blocks and stuff in it. You could create your own template if you wanted to that only dealt with Esri connections that had more styles in it, or in newer versions of Civil 3D that have the connector, you also have the ability to import styles or reference styles. So you could have a separate template just for Esri connection that would reference on top of things. This would actually, now that I'm talking through it, that'd be the way to go. Create a separate template that it's only for stylizing the Esri stuff. And then that way it's one master file. So if the CAD and GIS manager says, that symbol should no longer be a triangle, it should be a cross, they can change it in the reference template, and everywhere that style appears will update.
All right, and then we just set our GIS stuff to match, and that way, no matter where it's being used, it all looks the same.
You got it.
So that's really, I think, the ultimate goal is to have both groups working off the same set of data and have it look the same. And
yep. And this is a newer function of Civil 3D of Autodesk. Not many people are using the connector in the way that I've demonstrated for you today, but it's possible, and it just requires a little bit of work.
Yeah, super exciting to see, because man, going the shapefile route can be painful.
Absolutely, and we don't have to do that anymore.
Oh, nice.
Well, with that, thank you so much for your time today. I'll probably pop up my PowerPoint again real quick, just so you can have access to my email address if any other future questions come up. Feel free to get a hold of me, or if you have more questions about what ATG can do for you. The template that was done, is something that we do for firms. So not to throw in the sales pitch, but if you're interested in having some of that automation done, or you'd like some assistance on or some advice on how to set that up for your organization, feel free to reach out to us and see how we can help you.
Awesome. Thank you so much for that, Jason. That was super interesting. And I'd like to remind everybody that we have our program tomorrow kicking off at 9 a.m. And that'll be the last day of the summer series. So there's a ton of speakers, lots of good content. So tune in, don't miss it. Promises to be really interesting as well. And with that, thanks again, Jason. Thank you to our sponsors, and we'll see you tomorrow.
Yeah, thanks for having me.
All right, thanks.